At this point, throughout the Python is Awesome series, I've covered a lot of really cool and really useful Python libraries like Itertools and collections and all that stuff. But I haven't yet covered Functools, and there is a good chance that you've seen some Functools usage around, and Functools is actually one of the more useful libraries to have, especially if you're thinking about doing some really jank stuff. It's quite powerful in terms of that. So, if I just bring my notes to the other screen, there are 3 things I'm going to talk about. As always, I have kind of picked out certain things that I want to talk about, the most useful things that I can think of. In this case, I've chosen the things that you've probably seen around. So there is actually a really good chance that you've seen this already and maybe, don't know what it does. But there is some other stuff to it. Functools isn't as extensive as other packages, so there is only really 1 or 2 other things. The reason I'm not necessarily including those is because they're either alternative implementations of stuff or really complicated, probably to the point where it could have its own video. So I'm going to be covering wraps, partials, and caching today. So we're going to do from Functools, import wraps, partial, and then cache. The reason I'm doing like that is because generally speaking, from what I can tell, that is kind of the convention to do, from Functools import wraps, from Functools import partial, and just do that. So that's why I'm doing like this. And we're going to be predominantly working on a function called add, which simply, as the docstring says, adds 2 numbers together, and the docstring is important for something we're going to be showing you, and that just returns, and actually no, it's going to print x plus y, just saves us having to do a load of prints later down the line. So the first thing I'm going to show you is about the wraps. So the wraps is useful when using decorators, and it basically kind of adapts the decorator to have the correct information when you choose to present it. That was kind of a bad explanation, but if I'll show you what I'm talking about, and then it will make more sense. So we have our with greeting, which takes our function, and then we have our def wrapper, which takes our args and then quargs. And this is how you do it normally without functools.wraps. And then we're just going to have print hello world, and then we're going to return the func with our args and then our quargs, and then we're going to turn wrapper. So that is a standard decorator. I've already done a video on decorators if you're not familiar with them. And then we're going to decorate our function with our greeting decorator. And then what we're going to do is and I'm going to do it like this because I'm fancy. I've also done a video on what that means if you want to see that. And we'll do, add 2 and then 5, and then we'll print add.name. So this prints the function name, and then print add.doc, which prints the function docstring. And if I run functools tut.py, we can see that we get the hello world that is printed here. We calculate our sum to be 7, and then the name is wrapper, and then the doc is none, which shouldn't happen, or at least we don't want it to happen. So this happens because the function, this happens because of some weirdness. So when the decorator decorates a function, it returns this wrapper, which is executed kind of instead of this. So this gets passed into here, and then what's actually being executed is this. And when we return the wrapper, we're technically transforming this function into this function, which one doesn't have a docstring and has the name wrapper. So what we can do is we can decorate the wrapper with wraps and then provide the actual function object. And what this does is it changes the name of this function to this function and then adds the docstring to it. So if you run it again, we can see that we have the same hello world, we have the same 7, but our func name is now add, which is the correlative to this, and our docstring is adds 2 numbers together, which is correlative to this. So generally speaking, you pretty much always want to use Functools wraps, which is why out of all the things in this video, you've probably seen that one the most. So if you're ever unsure about what that did, it's simply just a mechanism. It's kind of an optional mechanism. You don't really need it, but it's just a mechanism to make, using decorators a little bit nicer and a little bit, kind of reduce unexpected behavior, which is kind of cool. So I'm just going to reset everything because we're going to continue using the same function. I'll keep the decorator there, but we'll just remove it from this. And we're going to talk about partials next. Partials are defined in the Python documentation as freezing kind of certain implementations to then be run later. I prefer to think of it more like we're preloading functions ready to be run. So a partial is essentially a function with an argument already pre-passed to it. So we can have our add here, or we can have, add 2 and 5 equals partial add 2 and then 5. So what this does is it creates a partial object where the func is our add, so this is the thing that's going to be called, and 2 and 5 are our arguments. So 2 is going to be passed to x, and 5 is going to be passed to y. And then if we do add 2 and 5, and then we don't pass any arguments at all, we get 7 once again, because we have preloaded 2 and 5 into our arguments. And this is particularly useful if you have like a for loop or something that's setting functions to like variables or something, because if you do it with a for loop, sometimes depending on the actual implementation, the arguments will always be set to like the last ones. It's kind of strange and weird to get your head around, but in a sense, the frozen thing kind of comes into it, because this is now set. If we had x equals 3 here, and then we set this to be x, and then we set x equals 4, this would still be 8, because we've now set x, because x was 3 when the partial was created, this is now set as 3. So it doesn't matter what we do with x later on, x will always be 3, or when we call add 2 and 5, we'll always be passing 3 to x. So I'm going to set that back. And you can actually do this with just a single argument. So doing something like this is perfectly fine. And you can do add 2, and then you have, say, 5, and then we get our 7 and 7. So what this is doing is it's preloading 2 as x, but y still hasn't been set. So we can then pass 5 in here. So this 5 is going to the partial object, which already has something for x. So this 5 is actually y, and then we add 2 to it as we do in the function, because x is set to 2 in the partial. Hopefully that makes sense. It's probably one of those things where you might need to kind of use it to get your head around it. But partials are really, really useful. There are some situations where you would actually want to use partials over lambdas. So lambdas don't have this freezing property about them. So if you need something to be frozen, like you had in that X example earlier, then you'd want to use partial and not lambda for that. So I was just about to move on to the next thing, and I actually forgot to mention something. You can use partial for methods as well, but you do need to use the separate partial method function rather than partial if you're doing that. They work slightly differently, but it basically works for methods. So there is a separate method implementation in case you want to do that sort of thing with methods instead of functions. So the next thing we're going to talk about, or the final thing we're going to talk about today, is the cache. So if I stick this here, this is now a cacheable function. So basically what this does is it caches the return value of a function based on its parameters. So I will actually need to do a return x plus y here, and then we will need to do print add 2 and 5. And to show this off, I'm going to import time, and then we're going to simulate a very complex adding function by doing time.sleep 2. So this is going to sleep for 2 seconds. This simulates a particularly expensive callable, which is kind of the only reason why you'd want to do it with a cache, because obviously if you cache something, that increases the memory complexity ever so slightly. But of course it does reduce the time complexity. So if we then print add 2 and 5, and then we print add 2 and 5 again, and I am going to do a print running, so you can kind of see. You can see that it's running, it's waiting for the 2 seconds, and then we get the 7 twice. Once when we're calling it from here, and once when we're calling it from here. You know, if I do not cached, this should make it a bit clearer. Cached like that. Oh god, what on earth have I done? What have I done? There we go. I think I just hit backspace by accident. So you can see the not cached result is 7, and the cached result, because it's the same parameters, are 7. But if we were to run this again with, say, 3 and 5, it would need to actually run again because they're not the same parameters. So this caching does allow you to pass different things into the function, but caches the same things. You know, if you're going to be calling the same function with the same parameters over and over again, then the caching is something you probably want to look into. One caveat is that the order of operations does matter. So if I were to say do 5 and then 2, instead of 2 and 5, it would run the first time, it would then run the second time, and then run the third time, because while the numbers are the same, X and Y are different values, and the cache has no way of knowing that you're passing the same numbers in. It just checks against the actual parameter values. So just keep in mind that ordering does matter. Even if ordering doesn't matter in your implementation, you might want to change it so it does if you are going to use the cache, especially if it's something particularly expensive. There is also, if you have like a property, which is actually how I learned about this existing in the first place, you have your cache property here as well, which essentially works kind of the same, just that, you know, the property only needs to run once. So you only want to do this if the property is probably immutable, but particularly expensive to calculate for whatever reason. So you then have this property, so whenever you access it again, it then accesses the cache, rather than having to do all the expensive calculations again. You can also do, well, it's essentially the equivalent of using the property and then the cache decorator separately, which you can do, but you also have cache property if you just want to use the one decorator for it. But yeah, that's everything I wanted to talk about with Functools. There are some other cool things as part of Functools, but as I said, they're either just slightly different ways of doing things, or, you know, so complicated that they need their own videos, which I'm thinking about doing, but I don't necessarily know. And if I do a video on this topic, you'll understand why I'm thinking about maybe not doing it. But yeah, if you like this video, then make sure to leave a like to let me know. This video is actually a really long time in the making. I've been meaning to make a video on command line parsers for some time. I just haven't necessarily known how I wanted to go about it. So, you know, whether or not I wanted to cover argparse or not, I have decided not to cover argparse because Click is so superior, in my opinion. It's so much easier to use. It's so much more powerful. There's so many more things you can do with it that there wouldn't be a point in doing a video in both. I don't think. So if you still want me to do a video on argparse, then do let me know in the comments. But for now, I'm not going to, and I'm just going to use Click, which ironically enough uses argparse's predecessor, optparse, which is really funny in my opinion. So yeah, before we get started, those of you that have been on the channel for a while may have noticed that things look a little bit different. Let me help explain why that might be. Yeah, I'm using a MacBook. It was actually given to me by my work, and I'm going to do all of my YouTube recording and editing on it as well. But I'm not going to do streams on it because I'm still going to do streams on my old Windows laptop. So yeah, things are going to be on a Mac now. Not that it's going to make much difference in the videos because it's still Visual Studio Code and it's still a Unix shell, but never mind. So to actually use Click, all you need to do once the terminal decides it wants to work, there we go, is to just do pip install Click, and I've already installed it already, so there's nothing to install, but it also has no dependencies either, which is actually really nice. So Click is the only thing you're going to be installing if you only install Click. It's not going to install like a load of other stuff. So to build our first command, we can come over here and do a main.py file. It can be called anything, but I'm just calling it main.py. And we can import Click. And to create our first command, what we do is just use the click.command decorator, and then we can pass any function in here. any logic in here. We're just going to do a really simple one for now. And then we need to call that function like so. I did a video already on this name equals main thing. If you haven't, if you don't know what that means, but if we now run that, we then get our, this is the name command, not the main command, but whatever. But we can also, if we do py main.py --help, we can see that our function is already set up to start passing commands. So basically, click command decorated function is a normal function that you can call in the normal way. It just does all this command line passing on top of that. So it builds a helper command as well, so you can use the help to do this. You might be able to make your own, I'm not actually sure. But now we can start adding options and stuff to it. And the first one I'm going to add is the version option one, which is really nice to have. You do need to have a version already. So say this one, like 0.1.0. If you pass the version in here, and then pass --version, you can see that we get a little bit of output. If you don't want all that output, then you can use, say, message, and then you have to use the old syntax. So that would be that version S, for example, if you just want the version number to show up. So that's how you do versions. Very simple. I believe if you're doing like a package for PyPI and it has a dunder version in it, it automatically finds it. I think it does do some things that are smart, but I don't remember offhand, so I might be wrong about that. But yeah, that'd be worth something, or that'd be something worth experimenting if you wanted to. But we are actually going to start doing arguments and options and stuff now. So you can do click.argument, and it is worth noting that in argparse, everything I believe is an argument, even flags. In click, they are separate decorators. So an argument is just things you pass to the command. An option is a thing with a hyphen in front of it, like a flag or something like that. And we are going to build, I come back to this example a lot, we are going to build a command that displays a little biography about ourselves, or a little profile about ourselves. So if I rename this to profile, and then I also rename this to profile as well. And then we have our argument, and then we take our names. And we're going to set on nargs equals 2. So the nargs is the maximum number of arguments. Or actually, I believe this is the number of arguments that would be taken. If you set this to -1, so if you wanted to support more than just a first and last name, for example, then it would take everything that it can find. So if there is a limit, then make that known. I'm not sure if you can set an upper limit, like up to 3. I don't know if you can do that. I couldn't find anything in the docs to say you could, but if you can, then do let me know. We're going to set it to 2 though, for the sake of demonstration, and then we pass names in here. So this names then gets passed in to our function, and then if I just print names, then we can see, if I use my actual name, Ethan Henderson, then we can see that it gets passed through as a tuple with, my first name and my last name as separate arguments. Yeah, as I say, if you have it as -1, then you can take, any number of arguments. I believe, if I were to just do this, yes, the argument names takes 2 values, so you couldn't do 2. If you were to do 3, like that, then it gets an unexpected extra argument because it's not then keeping track of all those. So those are arguments. Next I want to cover options. So these are a little bit more complicated than arguments. So these work similarly to argparse in that everything you pass in here as a positional argument, it will take as a potential flag. So if you use -a or -age, then it will be able to use both. And then if we pass type equals int, that will convert our input into an integer before it gets passed back out. And then we can also set a default equals 0, or whatever number you wanted to, if you don't want the argument to be, or if you want the argument to be optional. So we can then pass age in here, and then we can print our age as well. And I am 24. It's option, not options. Got unexpected. Oh yeah, because we need I'm completely forgetting how I built my own command there. But if you pass the -a24, so that was me demonstrating that you can't just pass it as an argument, you have to pass it as an option. See, it was intentional. Did it intentionally. But yeah, as you can see, the age is being printed out there. So we can now start kind of building a better command here, and we're going to set this to be text. And my name is dot join names, and I am age years old. And now if we print that as the text, we can see that our command, I don't know why it's doing that, is able to format a full sentence. So I can set this to, _age, and it will do the same thing. And if I leave it out completely, then it will say that I'm 0 years old. The next thing I want to talk about is Boolean flags. So there are actually two ways of doing this. The first is by using the isFlag option. So if I do say -s _shout and then pass isFlag equals true, this will know that it's a Boolean, and if it's provided, it will set it to true. So then you pass shout in here, and then we can add an extra check to say if shout text equals text.upper. So we can put everything in uppercase before we print it out. And if we did that, you can see it's all lowercase now, but if we had -s, then everything's in uppercase. And then we can pass -s and then -a24, and everything's in all uppercase. We can even pass just -sa, and it will do the same thing. So you can see it has, it has all the argument passing capabilities that you would expect. There is actually a second way to do this. So if I just comment that out, you can also do click.option. So say if you had shout and then /no shout, and you don't need to pass it in. If there's a slash in here, it will automatically be able to tell that it's a flag, and it will pass it to shout here. So if shout is provided, then shout will be true. If no shout is provided, it will be false. If it's not provided at all, it would also be false. So we could do the same thing. Oh yeah, I don't have short anymore, do we? Or the -s anymore, sorry. So if I did shout, it would do that. If I did no shout, it would leave it all lowercase. And then if we got rid of it, it would also leave it all lowercase. So if you wanted, I forget the official name for them, but if you wanted a flag that you could explicitly say no with, then that's how you do it in Click. The final thing I want to talk about in this video is files and stuff, because this is actually, it doesn't work necessarily as you'd expect. Click has its own thing to handle files, so I thought I might as well show it off, because I actually learned about it while looking at documentation last night planning this video. And it would have been good to know otherwise. So we're going to create a new option, and we're going to have f file, and this is going to be type equals click.file w. So to open it in write mode, and essentially Click will pass this file object through, and it intelligently performs file manipulation for you. So we could say if file. Then we can print saving to file.name is the name of the file you're saving it to, and then file.write text to actually write the text in. So if we then pass -f, say profile.txt, then we can see that it's saving to profile.txt, and then we have our profile.txt here, and it has the body of our text in it. My name is Ethan Henderson, I'm 24 years old. If I were to do this, say with the shout, then it would write the shouting version in the file. So before I go, there is one more quick thing I want to show you. I am actually gonna create a new file for this because I think it'll be a little bit easier. But I want to show you how to do sub commands. So we can import Click again, and if we have, say, if name equals main, and then we can call our soon to exist CMD function. So to have a group function, all you need to do is just do click.group instead. And then we can pass CMD, and then we can do this is a group command. And if you wanted to have a sub command, you would use at cmd.group .command. And this way is good because you can actually import CMD into a different file, and then you can use that group in that file. So you can actually split out groups into multiple files, which is really nice. And if you have subcommand here, we can print this is a subcommand like so. So if you run this now, you can see that it invokes the help by default. It doesn't actually run the command. If you don't want that to be the case, we can pass invoke without command equals true. And now we can run the command as a normal command. You can see in the help command, we have commands, subcommand. So if you run it with a subcommand, it runs the group command and the subcommand at the same time. Now you may want this to happen, you may not. If you don't want this to happen, what you can do is you can pass click.parseContext. You then have your CTX in here, and you can say if not CTX.invoked subcommand, then print that. So now if you run this, it just says this is a group command, and if you run this, it just says this is a subcommand. It still runs the group command, but because all our logic is inside the if not block here, or you could, if you had more complex logic, just have if ctx.invoke subcommand and then return. That's actually probably the more Pythonic way to do it, and then move this over here like that. So now only the logic will be run, or the logic will only be run if there was no subcommand to it, which is really cool. And you can be free, you can run certain parts of the command and not run others if you have different subcommands and all this, that, and the other. So that is the bare bones basis of Click. As I said at the start of the video, there's a lot more it can do. However, obviously, I don't want these videos to be hours and hours long. If you like the video, then make sure to leave a like and to let me know. It is all too possible in Python that you've seen something like this before, where dictionary is type hinted with dict string to any. Now this is often used when type hinting JSON objects, because generally speaking they are string to any. But what if you knew exactly what schema the dictionary is going to have? What if it was always going to have name, and that was always going to be a string, you're always going to have age, and you're always going to have jobs? Well, from Python 3.8 or from Python 3.7, if you have typing extensions installed, you can use the TypedDict to do just that, and we put a comma there instead. And then we can create a new class, and I'm going to call this profile T for profile type, and we can inherit from TypedDict. And then with the class attributes, we can set exactly what the thing is going to be. So the keys go in here as just the variable names, and then you can type hint them with the types that they're going to be. So for example, the name is always going to be a string, and as such, the age is always going to be an int, and the jobs is always going to be a list of strings. And now, if we set this to a profile T like this, we have a more complete type, or a more specific type for our profile. So if we get rid of jobs, we're then going to get an error from MyPy saying that we're missing the key jobs. If we bring that back and add one called gender, and I'm a male. I keep spelling it like that, I don't know why. But we can see that we have an extra key gender. The same goes for if we try and update anything out of turn. So if we try and update profile age to be 24, then we get an error here saying that it's an incompatible type. If we then try and add a key that's not part of it, then we'll get the same error as before. We have our no key gender thing. Now, of course, it's not always going to be the case where every dictionary you type in using TypedDict is going to have every single key included. Sometimes maybe the jobs might be missing. APIs do this a lot, and it's really annoying. But what we can do is we can import not required from typing, and then we can actually set, say, jobs to be not required. And if we do that, then we can get rid of jobs and we don't have any issues. But if we get rid of age, it's all good. We have the error saying we're missing the key age. So this is only available in Python 3.11, or if you have typing extension installed 3.7, I believe. If you don't have Python 3.11 and you don't want to use extensions, you can pass total equals false. But this isn't quite as complete because this makes any key optional. So we can now get rid of age and we're not going to have an issue. But I believe we can't add new ones. I think it will still shout at us if we try and add a new one. Yeah, there we go. There is also a required as well. Conversely, it's not required, though these things are required by default. So I guess it's just there if you want to be a little bit more explicit with your types, I suppose. And that's more or less everything I wanted to cover, besides just one little thing. So there is actually an alternative syntax that you can employ when defining type hints. I don't really think I prefer this as much. I think it's a little bit messier. I believe this is introduced in Python 3.11, but I might have been misreading the PEP, so feel free to try it if you prefer this. And we're just going to call this new profile T. And then we're going to use TypedDict as a class constructor. So here, you give your type a name, much like you would in a named tuple, so new profile T, and then we provide a dict itself with the key being the name, the key being the key and the value being the actual type. So to mirror the one above, let's put the not required back, and then we can mirror it in this one as well. And we can have jobs is not required a list of string like that, and then let's put it like that so it's a bit nicer. There we go. And now if we set this to be new profile T, it'll function exactly the same. So if we get rid of the age, it starts complaining. If we get rid of the jobs, it doesn't start complaining. If we then add a new key like this, then it starts complaining again. So either way is perfectly fine. The way you choose to do it will be up to you. I kind of prefer this class version myself. It's just a little bit cleaner than having all this around. But if you prefer the class instantiation, you can do that as well. The typing extensions, I haven't mentioned those, so I'll talk about it. You can do pip install typing extensions. And this brings all of like the future typing stuff over to previous versions of Python, so it sort of backports them. So say, for example, you can use the self type in Python 3.7 if you import it from typing extensions, which is kind of cool. I like that idea. I only found that out quite recently, actually, so I might start utilizing that at some stage. But yeah, that's pretty much everything. Metaclasses are, without a doubt, one of the most confusing aspects of Python. I get a lot of requests asking me to talk about metaclasses, and to be honest, until recently I didn't really fully understand them myself even, but I've since gone through, had another look, and it actually makes a lot more sense now. So I'm going to be kind of explaining the baselines of what metaclasses are, and I'm also going to be giving you a usable example of metaclasses. Now, it is important to note that there are people out there that say that metaclasses, or at least custom metaclasses, don't really have a place. And I think for the most part that is kind of true. Custom metaclasses, if you're doing something that you think needs them, then chances are there's a better way to do it. However, there are some situations where metaclasses can be useful, custom metaclasses can be useful, and it is worth knowing the baseline knowledge of exactly how metaclasses work, because they are fundamental to Python. So the thing you need to know for definite before you can understand what metaclasses are is that everything is an object. A function is an object, a class is an object as well, and the easiest way to define a metaclass is that a metaclass is to a class what a class is to an object. A class defines how an object is to be created. A metaclass defines how a class is to be created. Which may or may not make sense to people, but I'll spend the rest of the video trying to explain it, and hopefully it makes sense then. But if it doesn't make too much sense, then there's probably not too much need to worry about it, thankfully. So our story starts with the type function. Now this function is, well, it's actually a class, not a function. which is in itself an object. Hey, it's already getting confusing. But the type is the baseline meta class for every single object in Python. If you were to go through all the bases, you would eventually get back to type. Even type has itself as its meta class. This type provides the initialization routines for every class, and all meta classes need to inherit from type. And essentially this type is, as I say, the instructions of how to build a class. So you may have seen it use, type int, or you type like a variable, for example. So if I do var equals 5 and then type var, the result of that, it will tell you that it is an integer. If you do type int from there, it will tell you that it is type. And that is the actual meta class itself. But type can also be used to do more complicated things, such as dynamically creating classes. So if I were to do something like type, or if I were to do like foo equals type and then give it a name, and then give it a series of base classes, in this case an empty tuple, and then give it a dict of attributes, in this case an empty dictionary, that would be exactly the same as doing this. The two lines of code you see on the screen, so this line and these two lines, are completely and totally identical. Another example, if I were to do bar equals type bar, and this time I was to get it to inherit from foo, and then also give it another empty dictionary, that would be equivalent to writing this. So now bar inherits from foo, as we can tell by passing it foo as one of the base classes. You could pass multiple through and it works very much the same way. Generally speaking, you wouldn't use the type class to generate classes in this way. There may be some uses for it, I don't really know. But generally speaking, you'd use the standard class syntax because it's a bit more standard. But the type is another way to do it. One more example, if I were to do baz, and also we're doing a tour of metasyntactic variables. I actually recently found out what they're called, and the name is kind of funny, so I thought I'd share that. Do type baz, oh my god, I cannot type. And if I was to inherit that from bar, and also provide a number, which equals 100, that would be the same as doing this, where you inherit from bar, and then you have your init, like that, and then you set self.number equals 100. That is exactly the same as doing that. So now we have your class baz that inherits from bar, and a number gets set to 100. From here, I should really explain how type actually goes about creating a class. So if you go back to this foo example up here, just this bit, what we are doing there, if I zoom it in one more, if you remember what I said at the start, in that everything is an object, including functions and classes. If we define, a function that's called bar, for example, this is nothing more than an object. Bar is now an object that you call, and every class has a call dunder, which takes self and then all the arguments and keyword arguments that were passed to the function to begin with. And then you can just, we're just going to do a placeholder bit there. But this call defines what happens if we were to do something like foo with the brackets. So we're now calling, actually it would be more like f foo, and then if we were to do f. So we're now calling the instance. And this is exactly what functions do. They just are objects that have a dunder call method. And their logic is contained in this dunder call. And when a type creates a class, when you do the class instantiation here, that will call the dunder call of the class, and by default it will call it supercall, and then eventually it will get to type.dunderCall, which itself calls dunder new and dunder init. Dunder new actually creates the instance, and dunder init populates it with variables. Or attributes, I should say. Generally speaking, you don't need to define dundernew yourself unless you are doing some metaclass stuff. By default, that's set up to just create an empty instance, and then that then calls. Well, actually, it's the dunder call that then calls the dunder init that then populates it. This dundernew is useful for its own reasons, but it will be useful in our use case example because the new is generally used to kind of define how an instance is created. So one example of this, if I were to open a Python interpreter and do from pathlib import path and spell path correctly, if we were to do path like this, you'll see that it returns a POSIX path and not a path. And that's because the path object in the dundernew has a little if statement which is able to work out which operating system we're running on, and if we're running on a Unix or a POSIX-based operating system, like I'm on Mac OS, for example, then it will return a POSIX path. On Windows, that exact same code will return an NT path instead, which is ever so slightly different. And that's because the dundernew is returning a POSIX path object or an NT path object, which then gets initialized in its own way. And that is the power of the dundernew. But you'll see it in the example that we're going to do. I'm going to give it a new file. And we're going to create a meta class to essentially create a copy method on any class that uses it as a meta class. So to create a meta class, you just create a standard class and you inherit from type. Now this is essential. All meta classes must inherit from type, and all classes that inherit from type are inherently metaclasses. That's worth keeping in mind. And in this particular example, we're going to use the dundernew, and this dundernew takes the class, so it actually takes the class object, the name, which is the name of the class, the bases, which are the bases of the class, and the namespace, or sometimes it's DCT. Depends exactly where you're looking. But that is the dict of attributes, and you will realize that is the same as what we're passing in here. So we're passing in the name, the bases, and the dictionary that gets passed in here. And then what we do then is we can do x equals super dot dundernew, and then we pass the class, the name, the bases, and the DCT. For those of you that want to see the types, pause the video now, and this just gives you an overview of the types. I'm not going to actually do types because this is already kind of complicated as it is, and I don't want to overcomplicate it. So this X is actually our instance. It's not a class at this point. It is an instance. So I suppose you can think of it as self in a way. So we have now created our self. And what we're going to do here is we're going to create a method that gets attached to self. And this method is going to be def copy. And it's going to take self as an argument, which is going to be confusing. So I'm going to rename this to object. And we do return self.class. So this is now, actually, I'll do the whole thing and I'll kind of explain what's going on. So this copy is literally just instantiating a new object using the class of self and then giving it all of the dict. Hi there, editing me, just interjecting because I know people are going to call me out on this. The logic within that copy method is only really suitable for basic classes. If you want to do a proper one, then you would import the copy module and you would do copy.deepCopy self. The example I wrote in this, was just a real quick one, just to demonstrate how you can attach a method to an instance like this using the new dunder within meta classes. But seeing this in editing, I knew people would call me out on it, so I had to do a little note. Sorry about that. We will go straight back into the video now. You have x.copy equals, it'd be object.copy now because I renamed it. Object.copy equals copy, and then you return the object. So now we have an instance of our object that hasn't run through the init yet, so it doesn't have all the attributes that would define in an init, but it does now have a copy method attached to it. So doing, if you were to instantiate an object and run object.copy, it would now run. From there, we can define a class. So I'm going to continue our tour in meta-syntactic variables and call this cux, which sounds a lot funnier than it does on it looks on the screen. And we're going to set a meta class equals copyable. So this is now setting copyable as our meta class. It's not inheriting from it. It is setting it as the meta class instead of type. By default, it would do, meta class equals type. We're doing it meta class equals copyable. And then we could just, go about our business defining whatever we want. So I'm going to use my example that I do love dearly, which is kind of creating a little profile of ourselves. And then we can just have self.name equals name, self.age equals age, and whoopsie daisies, and self.jobs equals jobs. You would actually also probably want to do none there and do jobs or empty list rather than define an empty list. There is an entirely different reason why you want to do that, but I'll go into that maybe some other video. So now, if we define x equals cux, and then I'll give my name, Ethan, my age, which is 24, and my jobs, which is a software engineer, which is true. And then we do y equals x dot copy. And then we can see that if we print x dot name, and then I'm just going to copy this from my plans because it's just easier than typing all that out. And then we'll also do print x dot jobs and then y dot jobs. If we then run that, go away. I don't know what that was doing there. So it'd be copyable. You can see that the name is the same, the age is the same, and the jobs are the same. If we were to do y.age plus equals 1, and then we were to print this again, we can see that the age of our new class has gone up by 1, but the age of the old class has stayed the same. So they are now two separate instances. They are not connected to each other, which is, of course, what you want in a copy. So you may be asking at this point, why use a meta class and not just inherit from a mixin or something like that? And the answer is there isn't really much of a reason to do that. The only thing you are doing is saving some additional calls. So if I were to do print copyable new in here, and then if I were to do cux init, and then if I were to just copy this, and again, so we're now creating two instances using the exact same method. If you print this again, we can see that the copyable new only gets called once, whereas the cux init gets called twice. So for each new class of cux, I really should have named that something different, shouldn't I? It prints a new init statement, but the copyable new only actually gets run once, even though it does get run for every new, well, it at least works for every new instance of the object. If you were to inherit from a parent class or use a mixin or something, then you would be calling everything twice. So if you were to have, if every single object was to use this copyable meta class and you had like thousands upon thousands of instances that needed to be created, then you would only be running the initialization routine for the meta class once rather than twice, or thousands of times on thousands of objects. So that's one reason to use a meta class. Beyond that, there isn't really much that I could find. Generally speaking, there are some people that think the meta classes are useful. Some people that think that custom meta classes should never be used. It took me actually a really long time to come up with a use case that I could demonstrate in the video, like a genuine actual use case that has some merit. But even this may or may not be particularly useful. But that is the general idea of meta classes anyway. Even if custom meta classes are the sin of the earth and you should never use them, at least you should be able to understand what a meta class is and the role it plays in Python. Because, as I said before, in the same way that classes construct objects, meta classes construct classes. And as such, they are incredibly useful albeit confusing things. So that brings us to the end of the video. There are many secret, hidden, unknown things about Python. And today I'm going to show you one of my favorite things. It replaces the exclamation mark equals, not equals operator with what I think we can all agree is the superior double chevron operator. So to activate it, because it is still quite controversial, we haven't quite brought everyone around to it yet. We do from future import Barry as Fluffle. And this means Barry as friendly language uncle for life. I'll explain that in a bit. We import that, and now the rubbish, insignificant exclamation mark equals operator is gone. We can't use it anymore. Look. Try and do 1 not equals 2. Can't use it. With Barry as the BDFL, I looked that up. I already forget what it means. I think it's benevolent dictator for life. There's a lot of acronyms here. We need to use the double chevron operator. And if we do indeed use a double chevron operator, we can see that 1 doesn't equal 2 and 5 indeed equals 5, because 5 not equals 5 is false. 1 not equals 2 is true. As you can see, this is obviously the better operator to use. However, there is a small problem with this. So if we load up a file, like this test file here, and we do the same thing from future import Barry as Fluffle, and then we do print 1 not equals 2, we'll see we get a syntax error in the code. We can ignore that for now. And if we run pytest.py, ignore the fact that terminal's taking forever. I don't know why this computer's running a gas. It doesn't work. And that's because it's not supposed to. This was actually an April Fool's joke from 2009, detailed very clearly in pep 40. What? Firefox? Really? I think Firefox is playing an April Fool's joke on me now. We'll just load it like this. It's fine. As you can see, pep 401, BDFL retirements. I still think that means benevolent. I did actually look this up, but I can't find it. I don't think it's in my tabs anymore. The BDFL, having shepherded Python development for 20 years, officially announces its retirement effective immediately. The second point recognizes that the exclamation mark equals inequality operator in Python 3.0 was a horrible finger pain inducing mistake. The Fluffle reinstates the diamond operator as the sole spelling. This change is important enough to be implemented for and released in Python 3.1 to help transition the feature. A new future statement from future import Barry has been added, and the PEP was written on the 1st of April 2009. Now the reason I do it for this video is, 1, because April Fool's has just gone by. Because I don't particularly like April Fool's, I've gone with the this is an Easter egg and it's Easter video. But yeah, in truth, there's no real... Well, I suppose it is a secret operator. It is in the code. You can activate it. The only problem is you can only activate it in the interactive shell. But perhaps that is for the best, really. I believe there is a language that actually uses the diamond operator for not equals. I'm sure there is one, but I can't think of what it is. At this point in the video, I would normally do the whole spiel about making... About a month or so ago, I made a video on something called TypedDict. It's this really nice thing. It's sort of like a custom dictionary kind of thing, where you could supply types for your keys. You can have, set keys. You could set required keys. You can even have, set values for certain things. It was just a really nice tool for unifying dictionaries if you knew what type you were going to use. And I had a lot of comments in that video talking about Pydantic. Now, this is not something that I had heard of previously. I'd actually never heard of Pydantic before, which is amazing, actually, considering how many downloads it gets a month. It gets like 4 million or something, so I don't know how I hadn't heard of it. But I looked it up and I played around with it for a bit, and it's actually really nice, so I wanted to share it with other people who perhaps hadn't heard of it. So Pydantic it's sort of like TypedDict Plus in a way. It has actual strict type enforcement, which is actually quite nice. But it also has, a lot of extra features like validators and configuration that you can do, some of which we're going to be talking about in this video. Pydantic is quite expansive, and I want to keep, videos to a decent length. So I'm going to be talking about the things that are probably most commonly used, or the most common use cases of Pydantic, how most people would likely use it. I've already got it installed, but we can do pip install Pydantic, or you can do pip install with Pydantic, and it installs itself and the typing extensions, which is installed by quite a few things anyway, so it's not the biggest deal in the world. And to actually use Pydantic, we need to create something called a model, which functions relatively similar to a data class, though it's not a data class. That is important to note. So we could do from Pydantic import base model. If you do have any issues, I'm not sure if this is exclusive to VS Code, but if you do have any issues where it's not like giving you, proper suggestions or typing information or whatever, you can do from Pydantic.main import base model and it'll work just fine. I had that issue when I was testing this out. It was slightly weird, but whatever. And we create a model inheriting our base model. So our model is going to have our name, which is a string, age, which is an int, and our jobs, which is a list of string that I'm going to default to an empty list. My tried and true kind of example profile thing there. And then we can create our new instance of a model by calling profile and then give it a series of keyword arguments. It doesn't work with position arguments, so do keep that in mind. And if I pass jobs as software engineer, and if I just print P, whoopsie daisies, that's not the right thing I wanted, and now it's gone weird. God damn it. I don't know why Bash does that sometimes. Well, it'd be ZSH actually, not Bash, but there you go. So as you can see, it's printing out all our names and the values for them. The default string representation doesn't follow the quote-unquote standard that is defined. Well, it's not really defined anywhere, but there is sort of a standard where you have the class name and in brackets you would have this information. So if you did want to do that, you'd have to define your own repr. But it's not particularly the biggest deal. The other way you could construct a class is, say if we had a response that was, say, the name, I cannot type, was Ethan, and then the age was 24. I'm not going to bother with the jobs this time, I can't be asked. And then we could do P equals profile, and then we can use our double asterisk operator to unpack the dictionary and then pass in the rest. So this is sort of like simulating an API response of sorts. And you can build a model perfectly fine through that, and it will give you, the name, the age, and as you can see, the jobs defaults to an empty list there, which is really nice. The other nice but slightly odd thing about Pydantic is that it can actually do type coercion for you. So say, for example, if you passed age as a string, it would actually be able to understand that it was supposed to be an int. So if you do p.age, oops, I need to do type to demonstrate that, didn't I? You can see it's a class of int. So even though it gets passed in as a string, it then converts it out. If we were to do something like meme here, it would then give you an error, a slightly bizarre looking error, but it will give you an error saying that value is not a valid integer, type equals type parental integer, and it will give you the field's name as well. The same goes for something like the job. So if I did actually bother, and we passed it through as a tuple instead, remembering that this is a dict, not a class constructor, it would then pass it through as a list. So it would actually convert it to a list from a tuple. I don't know if there's a way to disable that, but do know that that is the default behavior. The next thing I want to talk about is something called aliases. Now, oftentimes APIs aren't written or aren't programmed to return their data in snake case, which is Pythonic. So you either, normally if you were to do a data class, you'd have to either manually convert them, or you'd have to write your model using camel case, or you'd have to do some weird crap, and it's just really annoying. But Pydantic has that handled for you through the class configurer or the model configurer. So you provide class config in here, and then you provide alias generator, and then you provide a function. So in our case, it's going to be called toCamelCase, and with any luck, it's still on my paste buffer. It is fantastic. So this method just converts, snake case to camel case. If we were to have, say, my jobs instead of just jobs, and if we were to provide my jobs in here, this is a naming conflict. So normally you'd have to either convert this to be snake case, or you'd have to set this as camel case and be non-Pythonic. But with Pydantic, it just works, in the words of Todd Howard. you can see that it's actually set that to be my jobs there. And even if it did use snake case, it would still work as expected. The function is perfectly able to handle it. It all works itself out and it all assigns itself to the right thing, which is actually really nice and saves a lot of effort. So I thought that'd be something I would show off. And also wanted to show off the configurer as well, because there are a lot of options in here. And this is sort of what I was talking about, where there's a lot to it. There's a lot of options. But the only other option that I want to show you is related to the final feature that I want to show you, which is validation. So this is a big thing that Python data classes don't have. Atras does have this. TypedDict doesn't, which is another reason why people prefer Pydantic to TypedDict. The validators are, very simple. They simply just take the input and validate it against a certain criteria. So say, for example, if we wanted to check that the age was greater than 0 when we instantiated the class, we could import our validator decorator from Pydantic, and then we can use that and then provide a string name of the field, so in this case age. And then this can be anything. So we'll just call this age greater than 0. We then pass the class, because the validator decorator turns it into a class method, so we pass the class, not an instance. And then we pass the value, which in this case is going to be an int, and then we return an int. And then we say if value is less than 0, we can raise a value error and say age must be greater than 0. Otherwise, we return the value back out. That's very important. So now, if we were to do this, we would see all the type checking and coercion happens first. So by the time it reaches this validator, age is already set as an integer. But if I were to set this as to -1, we would now get our custom error saying that age must be greater than 0. So these validators you can think of as an extension to the stuff that Pydantic already does. So it already checks the types. You're just adding extra things, as and when you want to. You could also check that the name is of a particular length, or that there's at least one job, or something like that. But ultimately the validation is entirely your call. You can just use this decorator and create any class methods you want out of it. One other really useful thing to keep in mind that I totally didn't forget the first time round, and I'm inserting this after the fact, is the validate assignment configurer. So normally, if you were to have, say, you have your thing and it's all valid, so we'll change this back to 24 as an integer, and it goes through all the validators and everything. But then what if you change it to say -1 after the fact, and then print p.age? What would happen is that it actually lets you do that. It doesn't run the validators again on assignment, unless you provide the validate assignment config argument and set it to true. And now it will do. It will say, if you're assigning it, then it will double check to make sure that it's actually a valid value. And if it's not, it will give you an error. I don't really know why this isn't on by default. Like, surely you would always want this. But it is at least something that you can enable if you want to. My guess is that it's probably quite a recent feature and that they didn't want to do like a breaking change, so they had it as an option that was disabled by default. That's the sort of thing I do if I have something like that. I imagine it would become default at some point in the future. But whether it's default or not, it is absolutely worth remembering about this validate assignment, in my opinion. Models aren't the only thing that Pydantic can help you with. There are instances where maybe you would want a normal function to check its types to make sure that it's actually using the right types. Pydantic has you covered with this as well. So if I just load a new file, say tut2.py, and then we do from Pydantic import validate argument, so it is a different decorator, so do keep that in mind. And we use our decorator on an add function that checks to make sure that it's an int, that x is an int and y is an int. Obviously in reality they could also be floats, but just bear with me here. And then we return x plus y. And then we have add 3.5, or we can print add 3.5. And if I run tut2.py, we can see that it runs perfectly fine. If we pass in a string, it still does the type coercion. So now if I just do print type of x in here, it actually converts it to an int before it gets in here. So it does exactly the same thing as it would normally do for your model, fields. But if you pass in something that is not possible, like a meme, then it will, flag exactly the same errors. So this allows you to bring Pydantic's model type checking behavior into normal functions as well. Whether or not you would want to install Pydantic in its entirety, if you just wanted to use it for this, is your call. There are other libraries that do it. I haven't used them, so I can't vouch for their goodness, I guess. But if you're already using Pydantic for other purposes, then it's worth using this if you feel like you want to. But yeah, that's all I wanted to show off in this video. There is a lot more to Pydantic, as I've said at the start, so make sure to read up on the docs if you're interested. This is generally all the things that I could see people using this for kind of a lot, or at least this is kind of the main use case, I suppose. Especially if you're building APIs and you want to create programmatical models for them, you would more than likely use Pydantic. You would have your aliases, you would use your double asterisk unpacking operator, you have your validators, you'd have all this, that, and the other, and you'd be golden. And Pydantic, takes a lot of the boilerplate out of that for you, which is really nice. Of course, if you found the video helpful at any point, then consider liking it to let me know. In recent months, AI seems to have dominated the world. Everyone's heard of ChatGPT, everyone's heard of DALL-E, everyone knows what these things are, and the vast majority of people have used them in one sense or another. However, not as many people know that there are actually APIs available for these things, and that you can actually use them in a multitude of languages, not just Python. I'm going to be showing Python off today, but you can also use them in JavaScript and stuff like that, which is really cool. So today I'm going to be showing you how to use ChatGPT in Python. So it's worth pointing out at this point that this API isn't completely free. It is very, very cheap, but it's not completely free. You do get a free trial, so you do get $5 worth of credits that expire after a good few months. So you have a good while to kind of trial it out. But after you run out of credits or after the credits expire, you do need to start paying for requests. The price for these requests is 1/5 of a cent, or maybe it's 1/5 of a penny. I can't remember which currency it used on the website, but it's 1/5 of whatever it is per 1,000 tokens. And according to the there's a little description at the top. It says that you can think of 1,000 tokens as about 750 words. So for every 750 words, you'll be paying 1/5 of a penny, which I actually think is quite a good price. It's really not very expensive at all. And to actually use the free trial, you don't even need to connect a credit card. So if that's a problem for you, then you can play around with this for a little bit and not be left out of the fun, which is actually really nice. The good part about it as well is that the API is really, really easy to use. In a sense, like almost a little too easy. It's like deceptively easy in a weird way. But hey, that can only be a good thing. So before we actually use it, we need to install it. So you can do pip install open AI, and I already have it installed, but I am using version, where is it? Version 0.27.6. Make sure you do keep this updated quite regularly, because obviously the new updates will be able to use the new models and all that stuff. But I'm using 0.27.6 for reference sakes. So if this video is a little bit outdated, then you know why. But for now, we can do import OpenAI. And then for convenience sake, I'm also going to do from OpenAI import chat completion. This just makes the code a little bit cleaner in my eyes. You don't have to do this if you really don't want to. And we need to set an API key first. So you can get an API key from the portal, but the way I've done it is I have a file here called key.txt. You would probably ideally want to do it in an environment variable if you wanted to, but I'm not going to bother doing that in this video. So if you're doing it like I'm doing it, you can just do with open key.txt as f and an open AI.api key equals f.read and then .strip. I did notice just then there was an API key path. Maybe it has a built-in file reader. I'm not sure. But feel free to experiment with that in your own time. If anyone does experiment with that, let me know. I've literally only just seen that. So that's why we need to import the main OpenAI module, because we actually apply the API key directly to the module. We don't actually create a client or anything to do it. And then to actually send a message up to ChatGPT, all you need to do is have response, which is our response data, chatCompletion.create. So it's a class method, and we set our model, which in this case we're going to be setting to GPT 3.5 Turbo. I'm not sure if it's using 0301 or 0302. I know 0302 is in development. I can't find any information to say whether it's out or not. So if anyone knows that, and do let me know. We're not using GPT-4 because you still need OpenAI Plus to be able to access that. But GPT 3.5 Turbo is perfectly fine. And then you provide a series of messages. Now these messages are a list of dicts. So each message is a dict. And these dicts have two key value pairs. The first of which being the role, which can either be user, which is from you, assistant, which is from ChatGPT, or there's a third one called system that isn't really used, or no one really knows how to use that at the moment. But that is available if you want it. And then you also provide the content, which is the content to send, or the message to send to ChatGPT. So in this case, we're going to do, how far is Earth away from the sun? Or I guess the sun. You can do it like that. And then from there, we can just print the response. So we're just sending our first message up. And if we just clear that, if we do pydemo.py, we can see that we get a response back. So if I just expand this terminal up, we can see we get a list of choices. You can actually specify to get more than one response out of the AI if you want to. I'm not going to be bothering with that because there's not much of a point. But if you did want to get more than one message out of the AI at once, your choices would be a list of multiple things. And you can see you have your message here, which is the content. The Earth is approximately 93 million miles away. And the role is assistant. You also get a created timestamp. You get an ID, which is the ID of your message. You get the model. Oh, it is 0301. Okay, that answers my question then. And you also have your usage. So your prompt tokens are the number of tokens in the message that you sent to it. The completion tokens is the number of tokens that it sent back. The total tokens is just the two added. You get billed for that many tokens. So all the tokens that you send to the AI and all the tokens that you get back, you are charged for. So do keep that in mind. I believe a single response can only have up to 4,096 tokens, though I'm not sure if that's 4,096 total tokens or completion tokens. For what I can tell, it's still quite a lot either way. I did some testing and I actually couldn't make it hit the limit with what I was testing it with. But yeah, so these tokens are what you get charged for. As I say, you get 1,000 tokens per fifth of a penny. So this response costs literally nothing at all, which is good. Now, I did say at the start of the video that it is easy to use, and it is easy to use, but it is a little bit cumbersome having to specify the model every time and then having to specify the messages as a list with all this stuff. And the reason you do have to specify as a list, I will mention, is because ChatGPT doesn't remember anything it sends back through the API. You're in control of storing the messages. So you can alter the message history if you want. You can even implant messages sent by the assistant. So you can actually force the assistant to say certain things, which is how people want to make applications using pre-prompts generally do it. But I'm going to be spending the rest of this video showing you how to make a slightly nicer version of this in a function. So we're going to create a new file, we're going to save it, and we're going to call it chatbot.py. And we're just going to copy all of this stuff again because you don't need to copy it back out. And then we need to provide or set a history. And this is going to be our message history. So all the messages that we send to the AI are going to go in there. We also need to do a send method or a chat method, depending on what you want to call it. And then we pass in content, which is going to be a string. And we can do history.append. And then you have your role, which in our case is going to be user. And then you have the content, which is the content that we're passing into the function. And then we get the response data back out. So we can do chat completion.create. Model, once again, is GPT 3.5 turbo. And then the messages is our message history. So we send the entire message history in. We then get the output, which is resp dot, or access. Apparently you can do dots for this, so I'm not actually sure it responds with a dict, more kind of some object wrapper. But either way, I'm just accessing like this. So we're just getting the output content specifically, appending that as well to the message history. So we can do role. I need to do a dot there, not a comma. So where the role is the assistant, and then the content is the output. And then we're going to return the output from the function. So this function essentially kind of handles all of our dictionary creation for us. It handles our message history management for us. And it allows us to just send a message in and get a message out without having to deal with anything else. Obviously, if you wanted to track your token usage, then you could, program this function to do anything you want, but I'm not going to be showing you how to do that in this. So simply beyond that, you can do while true, user input equals input, and then just have it like that. And we can have our response equals send user input. I guess we can do assistant. Maybe like something like assistant output would be a better variable name to use. And then we can print our assistant output to the terminal, and you'll see why I'm doing this when we actually launch it, but we're going to end with 2 new line characters rather than just 1. So if I run that, we don't need this to be this big anymore. If we run that, we get an input prompt, and then we can say, how far from the Earth, or how far is the Earth from the Sun? I can wait for a response. The average distance between the Earth and the Sun is approximately 93 million miles. And then we can, continue saying on, what about Saturn? And because we're passing in, this message here, and we're also passing in this message as well, so it's actually understanding the context, and it can respond back. The average distance between Saturn and the Sun is about 886 million miles. If we didn't pass through all the messages, it wouldn't have an idea. It wouldn't have any idea what we were talking about. So again, you can go on, continue going on. What about Pluto? Pluto is 3.7 billion miles, and you can see why I did that double new line for the end. Now it just gives us, a nice little gap between the prompts and the responses, and you can keep going like that. You could set message limits if you wanted to. So for example, if you only wanted to send the last 5 messages, you can create a deck. I do have a video on those in the cards, and you can set the max length to 10. Now, it's important you do it to 10 because you kind of want to keep 5 pairs of messages, because every message you send, obviously the assistant sends on back, and then that goes in the history as well. So it'd be the number of pairs that you want to keep times 2 if you wanted to do something like that. But that would be homework for you. One other thing I am going to show you though is that you can do this asynchronously if you wanted to. So if we send this to async def send, and then we can do await chat completion dot a create. So this now does everything it normally does. It just does it asynchronously instead. So this is perfect for something like a Discord bot, for example, where obviously everything is done asynchronously. So if you wanted a chat bot in that, you can just use ChatGPT to get the messages back. Obviously there'd be extra considerations as well, considering it's a group chat, but again, that is an exercise for the viewer. So if I actually need to import async.io as well to be able to run this. Async.io, and then I do love how isort didn't trigger then. You gotta love it. I don't know why I didn't trigger. Async.io.run, and then just our main function. And if you run it again, it will do exactly the same thing. So what is the average height of humans? Oh, we also need to do await send as well. It's weird. I did that exact same thing when I was planning this. What is the average height of humans? You can see it's making the request asynchronously. It's sending everything back asynchronously. It's doing all the same things it did before. So now the longest operation, which is, you know, actually getting a response back from the model, is all handled asynchronously, so it's no longer blocking. And then, you know, it's going to do like what about the UK, for example, and it will do exactly the same thing as it did before, just asynchronously now. So that is a, you know, really easy introduction into how to create a chatbot using ChatGPT, or more accurately, I suppose, you know, how to you know, get responses back from GPT. Obviously, if you wanted to create a chatbot, you can use something like Kivy. I think Gradle. Is it called Gradle? I'm not sure. It's quite good for that, I've heard. But if you like the video, then make sure to leave a like to let me know. At some point in a developer's life, they're going to want to create a website. And there are so many different ways to do that. It is absolutely unreal. In this video, I'm going to be showing you how to do it in Flask. This is perfect for people that already have a Python backend and don't necessarily want to stray away from that. Flask is a good one to get started with, as it doesn't really require a huge amount of background knowledge. And it's very quick to just get a website up and running. Which is why I'm showing you this. In this video, I'm going to be showing you how to create an authentication system, kind of in the way that Flask recommends you do it, so you can just build upon it. The reason I'm showing you an auth system is that it basically shows you pretty much everything you need to know, or at least all the basics. It shows you all the basics of everything you need to know in how to create a Flask website. So it's quite a good thing to go over. Plus, that will probably take, you know, long enough as it is. I did say it was quick, but there is still quite a lot to go over. So before we get started, I'm just going to direct your attention to the sidebar for a bit to show you the files that I've already got here. This Python version you don't need to worry about. This is just a PyM thing. But I do already have a CSS file and some HTML files. I'll be showing these in more detail when we're actually talking about them. But you can download these directly. I've got them hosted on a file server, so you can download them using the links in the description. It's just easier because HTML isn't really the focus of this video, but we do kind of need to have these things in place. So I'll show them when they're necessary, but I won't go into them in too much detail. So to create an app, all you need to do is create a folder. I've called mine app. You can call yours whatever you want. And we need to put a dunder init.py file into it. And then we need to install Flask, because I've just realized I haven't done that yet. So to do that, we just do pip install Flask, and this is all you're going to need. It will install quite a lot of dependencies. So you can see click is one, and I'm not sure how you pronounce this, Werkzeug. That looks quite a German word to me, but I don't know. But that is going to be used quite a bit as well. So it kind of installs everything you need to use, which is quite nice. Or at least everything we need to do with this. So to start, we do from pathlib import path, and then from Flask import Flask, and then we're going to create a function called create app, and we're going to have a single keyword argument test config equals none. So this is if you're running this in a test environment, you may want to pass the test configuration through. We're not going to be doing that in this. We're not really going to be worrying about configs too much. But it's nice to have. We do app equals Flask, and then we need to give it a name. So we're going to give it the file name, and we're going to say instance relative config equals true. And this basically just means that any config files will be placed in the instance directory, which is a special directory that Flask will create the first time you run the application. That is designed not to be committed. So you just put everything in there, and this will contain the database and all that as well. As I said, we're not really going to be worrying about configuration files, but this is where you would put your configuration file if you had one. So now we're going to create an instance, path, path equals, and this is just going to be a pathlib object of our app.instance path. If you don't want to use pathlib, you can use OS, but I do like my pathlib. And we're going to make sure that it exists. And if it doesn't, we're going to create it. And then we're going to do app.config.from mapping, and we are going to create a few keys. The first of which is going to be a secret key, which for the now we're just going to set to dev. And we're also going to have a db path, which is our instance path slash app dot SQLite. And we're just going to use an SQLite database for this. You can use other databases, but it's just easier to start with this. And we're going to say if we have provided a test config, then we want to overwrite the default config, or any default config keys, with the ones we passed in. Otherwise, we want to load, where possible, a config from a Python file called config.py silent equals true. This silent equals true basically means that if it doesn't exist, then it won't complain at you, which in our case it doesn't. You only need to do this kind of once you're in production and you have your secret key, you put that in there, but the DB path is always going to be the same. Now we just need to create an index page, so we can do that using the app.root decorator. And this is how you create any page. You create a root, and we're just going to set it to be the index. And we're not going to bother giving it a name because we don't need to. And then we're just going to make it return hello world just for the sake of it existing. And then we just need to return the app. And we're pretty much done in creating the app itself. So we can move on to creating the database. Now I'm going to start with the schema.sql file. And we're going to do drop table if exists user. So the way we're going to run this, this will only be run when we want to reset the database completely. And then we're going to create table user. Inside that table, we're going to have an ID, which is going to be an integer, which is going to be a primary key, which is also going to auto increment. You may want to use UUIDs in production, or maybe like hex IDs or something like that, just for the sake of security. But for now, we're just doing it like this. And we're going to have a username, text unique, not null, and a password. That's going to be text not null. And we don't want that trailing comma actually. If you do get an error saying there's something wrong around here, you've probably put a trailing comma in. SQL really doesn't like those. So now we have our schema in place. We can create a new DB, and we're not focused in because of course macOS. Bloody hell. Create a new db.py file, and we can import SQLite through. And we can import click, and we are using the right env, nice. And from Flask equals current app G. Now this G is sort of like a global store in a way. It doesn't really mention global in the documentation at all, but I kind of see it as a global store. And current app will be the current app at the time of the request. So these Flask uses a lot of magic to do all its stuff, and all these current app and G. These are all objects that kind of magically update themselves. I don't really know how that works behind the scenes, but it does. It works. So who am I to complain? So we're going to have a function here called getDB, and we're going to call this from outside this quite a lot. We're going to say if DB not in G, then we don't have a DB, therefore we need to create one. So g.db equals SQLite3.connect, and we're going to have current app.config, and we want to connect to our DB path. And then we also, for convenience sake, want to set g.db.row factory equals SQLite3.row. And this will allow us to access rows in dictionaries. So normally SQLite3 will return it as a tuple. With this, we can access it like a dictionary, which is quite nice. But if you use dict there, it doesn't work. So just keep that in mind. And then we're going to return g.db out of it. We're also going to have a function to close the DB. And we're going to, it takes an exception, which defaults to none. We're not going to deal with that right now. But it does take one in case you did want to use it. And we're going to pop the DB from G and assign it to a variable called DB. This is what the walrus operator is doing. And we're going to db.close. And then we want a click command to initialize the DB. And we're going to call this initdb. Do init, whoopsie daisies, initdb command. db equals getDB. And then with current app dot open resource schema.sql. So we're loading in our SQL file, and this will always load it in as a bytes file. So do keep that in mind. db.execute script f.read.decode UTF-8. This is what I was saying. So we need to decode it when we load it because it loads it in as a byte. So I don't think there's a way around that. Oh, there you go. You can set the mode if you want, but okay, we're just going to leave it as default because why not? And then we want to def init app dot tear down app context close db, and I'll talk about that in a second. app.cli.add command init db command. Now I'm going to spend some time explaining all this, so feel free to catch up if you are copying at home. So this click.command init.db, this is what we're going to use to create our database. So we're not going to rely on the first instantiation of the app or whatever to do it. We're just going to create it ourselves using this command. So we get the DB and then we open the schema SQL, as I said. This is why we have the drop table if it exists, because when we run the command, we want to completely reset the database and start it from scratch. So that's what we're doing there. In this init app, we're going to be calling this from somewhere else. So we're setting close DB to be called whenever the app tears down. So when the app is being closed, we're registering the close DB function to be called when that happens, which is why this takes an exe, because that will be passed by this. But this is basically just saying that when we close the app, we also want to close the database. And we're also adding a CLI command, which is this function here. So now we can run this directly from the Flask command line, which is quite nice. So we can do that now, actually. So we can do Flask. I'm actually going to clear the terminal. Flask, see if I remember how to do this. I think it's app double dash. No, it's a double dash. It's double dash app, then init db. No, that's not how I did it at all. Oh no, because I haven't added the command. There's a step I've missed. That is my fault. So remember when I said we were going to do something a little bit later on? This is where we're doing it. So if you come down here, so between our root, I suppose it doesn't really matter exactly where you do it. I do from dot import db and then db.init app. And now it will work. So if we do this, then as you can see, we have this instance directory and we have this app.sqlite in here. Now using my extension, we can see that we have this user. I forget what this extension is called exactly. I think it's just called SQLite Viewer. You can see we have the ID, the username, and the password, but you don't have any records because no one's created an account yet. But you can see that it does exist, and this is just a helper table for SQLite to do all its stuff, mainly for the auto increment, I think, because it needs to keep track of where it last was. So now that we've done that, we can actually start creating our first view. Actually, you know what? I'll show it running, because we can do that. So if we replace initdb with run, now we get this run, and if we go to here, and I don't know where that's going to open, it's going to open across. Cool. You can see, it might just be able to see, let me zoom in a decent amount there. You can see it says hello world, and we have our website and it's all loaded and it's all fantastical and magical. But now we're going to create our first proper view. And to do that, we need to create a new file, and we're going to call this one auth.py. And we need to import quite a lot into this one. So from Functools, import wraps, and then from Flask, import, and get ready for this, blueprint, flash, G, redirect, render template, request, session, oh, not that, session, and URL for. You can, of course, just import Flask if you really want to, but we're doing it in the way that Flask tends to do it in its documentation. And then from Werkzeug, Someone please tell me how to pronounce that before I offend anyone else. .security, import, check password hash, and generate password hash. You can probably see how those are going to be used. And then also we need to do from app.db import get db. So this is our first time that we're actually having to get the db from the app. And now we need to create a blueprint. So BP equals blueprint. We give the blueprint a name. We give it an import name. So we just pass done the name. And we give a URL prefix, an optional URL prefix, but we are doing it in this instance. And we give it /auth. So a blueprint is sort of like a sub app. So you can create routes onto a blueprint in the same way that you could an app. And it will use this URL prefix automatically, and you can have, you know, blueprint elements, all sorts. So it's sort of like a sub app in a way. Or if you've built Discord bots before, it's kind of like a cog or a plugin or something like that. It essentially just plugs into the main app, so it can help with, you know, structuring the code, so you don't have it like all in one file or something like that, or you don't have to import everything from everywhere, even though we kind of are, but that's beside the point. And it also means we can do something like this. So if we register a route called register, this will now be triggered if we go to auth/register, not just register. So it's taking this URL prefix /auth, and then we have the register in that, which is quite nice. And in this method, we need to provide a series of methods. So we're going to provide get, and we're going to provide post. We'll do def register, and we don't need to pass anything in. And I'm going to do the get first. So if it's just a get request, and all we need to do is return render template auth/register.html. We're going to come back to that template once I've written the rest of the function, because it will probably make a little bit more sense at that point. But if we're doing it, I just realized I spelled register wrong. If we're doing just a get, then all we want to do is render the web page. However, if we are doing a post, that means someone has queried this page and has attempted to create a user for themselves. So we need to add them into the database. So we can do db equals get db, and after that we can get the username equals the request.form, and then username, and then the password, which equals the request.form password, and then our error equals none for now. After that, we can check if our username, or I suppose if not username, that means no one. That means the person didn't provide a username. So we can set the error to be username is required. Elif, it'll be an elif, not password. The error equals password is required. And then if there's no error at this stage, that means that everything has gone fine so far. So we can try and insert the user into the database. So we can do a db.execute, insert into user, username, password, values, and then we're going to use our prepared statement syntax. And then we want to pass in username, and we want to generate a password hash for the password. So we don't want to store the password in plain text, because that's incredibly insecure. So we can generate a password hash, meaning we store the hash. Now with a hash, it's one way. So we can generate a hash for the password. You can't get the password from the hash, which is why we do it in a hash. And then we can do db.commit to commit them in. And then we can return, if everything goes okay, we can return a redirect URL for auth.login. And I'm just going to do an accept pass for now, just so Black can sort that out. Thank you. So this redirect URL for auth.login, we haven't actually created an auth.login route yet, but if we say had login here, then this auth.login would be able to find that route. So you don't need to provide a URL, meaning the URL can change as many times as you like, but so long as the function name remains the same, then it will be good. It's just a much nicer way of doing it than hard coding everything. But except if we run into an integrity error, then the user, a user of said username, and we're gonna do -r so we get quotes, is already taken. Please try another. Very common. And the end of everything, if there was an error, then we need to then flash any errors with the category of error. So this flash kind of flashes a message into session storage for the next request to pick up, or any future request beyond that. So a flash store has to be manually cleared, but it's essentially just stores messages in place. So if you have like alerts or something, then you can put them in here. And then we rendered a template. Anyway, so if we then move on to our login, which is kind of very much the same thing. So we now have a bp.root /login. And then we have methods equals get, and then post again. And it is largely the same stuff. So I might copy paste some of it. Yeah, we'll try copy pasting it just for the sake of time. And then we'll change the things we need to change. So I need to zoom this out a bit just so I can see what I'm doing. It would actually help if we created a function. That would be that would be of some use to someone, I imagine. So with our login, we need to change. So we need to actually get. So this part needs to change. So our username, our password, our error, and our DB all stay the same, but we now need to get a user from the database instead of checking the username explicitly. So we select star from user where username equals our username, and we just do a fetch one on that actually. Fetch one, so that will get our user. If we don't have a user, then the error equals incorrect username. We know they're not registered. And there needs to be a full stop at the end of that as well. If our password isn't correct, so we need to check our user password against our password. So this is basically checking the password hash of the currently stored password with the password that we've taken from the form. If that doesn't match, then we submit an error of incorrect password. Then you have if not error, then actually this is largely different. We do a session.clear. We're going to do a session user ID. Whoops, equals user ID. And then we return a redirect of wherever you want. I'm just going to send us back to the index page just so we can see it. If there are still any errors, then we need to flash them. And then we need to redirect to a login instead of register. So what we're doing here, just to kind of catch you up. So we're clearing the previous session of a previous user. We're then creating a new session with a new user ID in it. And then there are a few other things as well that I want to do before we run all this. So we need to do a logout as well. So we're going to have /logout, and this one's going to be very, very, very simple, thankfully. All we need to do is session.clear, so just clear the user, and return redirect URL for, and we're going to send them back to the login page, just for the sake of it, and that's all we need to do. There are a few other helper functions as well, but I do want to show it running first. So if you kill the development server, run that again. Go back here. So if you then go to, this is really small. Sorry, I can't make this any better. Auth/login. Maybe register. I don't know why. Oh, that's right. I've forgotten to do the thing again. So every time you add something, you need to add it into your init. It doesn't just automatically work, as I apparently keep thinking it does. So we need to import auth, and we need to register our blueprint auth.bp. Once we've done that, and I'm going to restart the server just to make sure. Blueprint is no attribute logout. That's because I have done that badly, and that's supposed to be root, not logout. And then we need to rerun our server again. And now it works. So this is partially, I'm not sure why these, I think these are doing wrong. But it won't look like this if you don't have the styles.css. That's kind of what's making this look a little bit nicer. So if we type in a user, just say, I'm going to have to burn most of those email addresses out. And if we say our password is memes, and we hit register, then we are registered. So it's redirected to our login page. And if we go back to our app, if I go into the app SQLite, we can see that we have one row, Cabra, and then this is the hash of our password. So, oh no, God knows. Oh, it's a SHA-256. There we go. I'm not sure what this is all about at the start. Maybe it's just something to throw people off. But if we then do, say, Cabra, that's still going to bring up a load of email addresses I don't want you to see. And memes, then we get redirected to Hello World. Otherwise, if you get the password wrong, it'll come up here saying incorrect password. If we get the username wrong, it'll say incorrect username. If you go into register, if you just hit register, you'll get this error saying please fill in this field. So if you try and re-register as Cabra again, it'll say user Cabra is already taken. Please try another. That should probably be username, not user actually, but you get the idea. So while I'm here, I do want to show you two more things. So the first of which, I don't want to spend too long on this because this isn't a HTML tutorial, but I do want to show you these templates down the side. Editing me here, just butting in. I did actually do an explanation of these HTML templates, but looking back in the editing booth, I did a really bad job, so I'm just doing it again. So these HTML templates are obviously built on HTML, but they use something called Ginger templating. And Flask supports this by default. And they work in these blocks. So you can have a block. Actually, we'll come back to the blocks because it'll make a bit more sense. But you can have these like logic statements. So all these logic statements are placed within a curly bracket and a percentage sign, and then the same on the other side. And you can also have variables passed in as well. And these can be, passed in from Flask directly, or in this case, they're passed in using the for loop. So in the if loop, G is automatically available to all Ginger templates. So it just looks if g.user. So if we do have a user, then we display, this bit. Otherwise, then we display this. And then we have to do an end if block as well. And then the for loop, works in much the same way. So this get flash messages is always available as well. So this just gets all the messages that have been passed into the flash function, clears all of the flash messages, and then you can iterate through them. So in this case, you're doing a class flash, and then we are passing in a message. So you could do like an alert in the top corner or something if you wanted to do something like that. And then again, you have to do the end for. These blocks are useful if you have, say, the login page, where you have this block header, and you can see it extends base HTML, so it extends this, but it provides the blocks. So we have our block header. I'm not actually sure. Oh, that's down here. So our block header is our block title, which is login. So our title we've set to login. So the title will go into our tab title up here using the block. And then this is in a block header, which has the title in H1 tags. And then this will be inserted into here. So it is basically, it is a templating tool pretty much. And then we can have our block content as well, which is the content specifically for that page. And here we just put in the form, and then we put it just in a block here, and then this will go in here. And the same for the register. The register is basically the same, except instead of login, it's register, and that's literally the only difference between the two. So I'm going to hand back to past me to explain the rest of everything. The other thing I want to quickly show you before we go is some extra stuff that you can do for login sessions and stuff. So if you do bp.before app request def get logged in user, G.user. So this will actually get, okay, so this will be called before any request, and it will get any logged in user. So you remember somewhere up here, I think we were setting something or other. Oh no, yeah, we were setting the session user ID. Well, here we're actually going to be querying the database for that ID and setting it as the user to be used for the request. So if we do that with get db.execute select star from, we probably actually don't need to select the star really, but it's whatever. User, well, actually, you know what? It's probably a good convention to just select the ID. Actually, it would just be the select ID, wouldn't it? Not user ID. Where ID equals that. User ID, that needs to be in brackets, and then a trailing comma, and then dot fetch 1. And then if user ID, which we're setting to session.get user ID, else none. So this is essentially getting the user ID from the session and assigning it to a variable called user ID. If this variable returns none, then we just return none out of this as there's no user logged in. However, if we do get a user ID, then we actually want to get the user from the database, and we can probably just do select star because we don't really need anything from it, where the user ID equals user ID. So we're getting a logged in user there. So that's incredibly useful. And this, you don't actually need to do anything other than that now. It will just automatically do that for you whenever you make a request. If a user is logged in, g.user will be available to you. We can also do login required. So this is a decorator. We pass in a view. And then we wraps the function and we pass view in. So this view is our callable that we're trying to decorate. So say, for example, if you wanted to put login required on the logout, for example. And then we have def wrapper quags. So this just works as a standard decorator. And we return view quags if g.user, else redirect URL for auth dot login. So what this is doing is it will make sure, actually we need to return the wrapper as well. So what this is doing is it's checking to see if g.user exists. If we do have a user logged in, then it will return the page as normal, as login is required. Otherwise, it will prompt the user to log in, which is pretty cool. So I think we've been here long enough. That is the basics of Flask development. Hopefully that makes sense. I know I didn't cover the HTML templates in too much detail, but chances are if you're building a website, you probably already know how to do at least some of that, but you can of course look it up. Otherwise, I just didn't want this video to be stupidly long because it's already going to be about half hour. Of course, if you like the video, then make sure to leave a like to let me know, and maybe subscribe. In the last video, we talked about how to create a website or web application using Flask. We went over some basic authentication stuff, went over how to create and manipulate a database, all that good stuff. In this video, we're going to be taking it a step further, and I'm going to be showing you how to include Python in the front end as well as the back end using something called PyScript. This has been around for a little while, but its kind of proper release only happened in the last few months. I've been meaning to do a video on this for quite some time, and seeing as I did the video on Flask, I thought it'd be a good opportunity to do this as well. So as you can see, I've created a Flask view for us to use. So this just has our /view to actually load the HTML page that we're going to be using. And then it also has a separate route that will make a little bit more sense in time. But if you want to be able to load Python files directly into the code itself, then you need something like this. But I'll explain more about that when we actually get to it. And remember, when you create a new view, always register the blueprint in the init.py. So in our static folder, or in our static, we're going to create a new folder just called data in this case. And we're going to create a file called analytics.py. We're going to be doing some data analysis with our thing today. This is just going to be really simple. I'm not going to spend a huge amount of time in here. In fact, I'm going to copy paste it and just run through it. So what we're doing is we are loading a CSV for a file that we're going to pass into our function. We're creating a figure of a particular size. We're creating a line plot using Seaborn, and we are doing some fancy stuff with the xticks because matplotlib sucks, and then we're returning the figure back out. And that's all going to be very important when we build our HTML file. So if we go into templates, and now if we go into data and create a new file called view.html. And we're not going to be using any of the other base templates or anything. We're going to be doing this one completely from scratch just to show you how this all works. So we can do a HTML tag here, and then we can have our heads. It's probably good I type all this out actually. Actually, you know what, I might copy paste this as well because it's a lot of annoying links. So you can have a link, rel style sheet href PyScript.net/latest/PyScript.css, and this just allows, this just imports all the CSS stuff for PyScript. So it has, you know, various views and all this, and it all works like that. So that just imports that. And then we do script to first source with the PyScript.js as well. This just imports all the actual PyScript code, all the JavaScript code that it needs to run. So it's all basic stuff. It won't work without any of that. Now we're going to do the body, and we're going to do some PyConfig. So this becomes available to us with whatever it's called installed, PyScript. And we're going to specify some config options here. So we're going to have our packages. So we need pandas and we need Seaborn. Seaborn will import matplotlib on its own, so we don't need to specify that. But this is basically if you need any external packages, and this is where you put them. And then when the page is loaded, in the venv that PyScript creates, it will install these packages into it. And then if we want files, actual Python files in it, then we need to do a fetch like this. And we do files equals analytics. In our case, analytics.py. And this is why you need this file here, because I couldn't figure out a way to make it work without a web server. Actually, it completely outright refused to do it without a web server. But it will make a request to /data/ and then the name of the file. So we've got a root here, which is basically taking a file name, and then we take our file name as a parameter. And then we use the send file function, which is built into Flask here. And then we load the file that we want to load. So in our case, it's in static data and then analytics.py. If it doesn't exist, I think PyScript will just throw some sort of error. But in this case, because we're actually specifying it here, then it will be fine to use. And then from there, we can actually use that file and import this plot into it, which is pretty nice. So once we've done that, we can get into the PyScript body. And then we're going to be doing from pyodide.http import open URL import analytics, and we're going to be getting our file to analyze from my file server. So I did this so I could show this off, and I'm fully aware that pandas.readcsv can accept URLs as well. I just wanted to use the open URL to demonstrate it, to show its uses, because you might find uses for it other ways. But on files.carbo.xyz/usources/PyScript/this, I have my YouTube analytics data for January 2023. Feel free to have a look. I don't care. I'm also deciding to use one of my files just so I don't infringe any weird copyrights or anything. But this will actually download the file and then save it as our file in, I think it's a buffer or something, an IO buffer. And then we specify our fig, analytics.plot, and then we send in our file buffer in here. And then the reason we actually need to return the fig out, and we don't do plt.show in here, for example, is because that won't work. You do actually need to use the display function. So we do fig, and then target equals graph, which we'll come back to, and then append equals false. I'm not really sure what that does. It was just in the example. I think append equals false means it will replace it, not add another one if you're like doing something else, for example. And then we just do the rest of our stuff in the body. So we have our H1, and we're just going to call this analytics data January 2023. And then we have a div section, which is going to be ID of graph, and then that's it. So this graph and this graph match. So our target is saying what element to put it into. So it looks for an element with an ID of graph. It finds one, or it finds one. I went to say finds and found at the same time, and it came out really weird. But it finds one in this div, and then it will put it in the div, which we haven't really stylized at all, but it doesn't matter. And that's all you need to do. So with that, we can go back. It might be still running. It's still running. I'm going to reset it just to make sure. We're just in the same folder and everything. So, and I'm recording this straight after the other one. So if we do data/view now, you can see it downloads PyDict, it does the startup, does the thing. So you can see the actual element, the header element's already there. So it renders the page first. And now we got a graph that is way too big. Why? Oh yeah, because I've zoomed it in massively, haven't I? You see we have, we actually have a label for it. Yeah, this is why it was being weird. It didn't separate these, it just had them all. I don't know why it did that. It doesn't normally do that, but whatever. So we have our dates and then we have our time. So, wow, on the 7th of January, I got a lot of views. And then there's our graph. There's a picture of our graph actually in the web page, which is really cool. So that's just kind of a very basic example of how it can work. But this is pretty much all you need to know. Inside of PyScript, you can write all the Python you want. And using this files, fetch, and a web server, you can import entire modules if you want to. You can import Python files. If you want to do your development in here and have the luxury of type hinters and checkers and all this, that, and the other, be able to do it properly and just import your Python code in here and then just call it, which is kind of how I would use it, really. But it really depends. If maybe it's, I was going to say if it's closed source code, it's going to show up in the HTML anyway. So there's no point in doing anything like that. You might as well just have it all on the show. But yeah, that is a very quick. If you're anything like I was, it's on your bucket list to create a package for the Python package index. I'd been wanting to do it forever, but I'd always been too scared to because it was too hard, or I didn't think I was ready for it. And then I actually did it and it wasn't that hard at all. And I wanted to make this video to show you that it's not that hard to do it yourself. As long as you have a good idea and a way to do it, it's actually very easy to put something onto the Python package index and share it with the world. And maybe, who knows, your package will become the leading package in its field, or maybe you're breaching into, I'm calling it a new market as though anyone sells anything on this thing. But you're creating something new that no one's ever done on the Python package index before. I actually originally started this video in the code editor, and I finished it, and I realized I actually should probably show you around the console first. So I'm going to do that, and then I'm going to go back into the past. Just the way these videos work sometimes. So this is the main console for the test Python package index. I used the test one. I didn't want to push a test package onto a live repository. This test one is a good one, or a good place to like test your packages to make sure everything's working properly and to make sure everything looks okay. I would recommend using this first before you use the main one. But this is your main projects. As you can see, I've tested quite a few. Some of these actually came to fruition. Some of these did not. Actually, a number of these didn't really go anywhere. This is the one that I just finished making a video of. You have your organizations, you have your account settings in here, which is actually pretty useful. We're going to need to be doing something in here. You also have this publishing thing, which is just documentation by the looks of things. Okay, so we want to go into the account settings because I want to show you how to create a token first, because it's actually quite useful to have. Regardless of whether you're going to be uploading them in your own shell or whether you're going to be doing it in GitHub Actions. I'll talk about that in a future video. You're going to want to have a token. So you want to come down to where it says API tokens, and then you want to click Add API token. You want to give it a name, so we're going to do like, video. Permissions, upload packages, that's the only one you get. And then you have your scope. So you can choose to create a token for all projects, or you can choose to create a token for just an individual project. If you are wanting to create one for just an individual project, the project already needs to exist. So you need to have already pushed it once using your username and password. So do keep that in mind. That also means that you can't push the very first version using GitHub Actions or any other CI like that. So yeah, perhaps your all projects one is the better way to go, because then you can just create a new project using it. And you just need to create a token. And you have your token here. I'm not going to bother blowing this out because I'm going to delete this. But you need to copy the token and put it somewhere. It doesn't really matter where. But if you forget it, then that's it. This token is gone. It won't actually show you this token ever again. So do keep that in mind. It gives you some instructions, but I also talk about that a little bit more in here. And you can also, one thing I don't talk about, this might have been new, is that you can set your environment variables in this PyPI RC file. PyPI RC file. It's not PyPI because that gets confused with distribution. But you can put them in here like that, so you don't ever have to supply them with Twine. But we'll talk about that a little bit later. So now that we've created our API token, we now need to create the actual, all the files that needed to build and upload the package. So I'm going to go back to past me, and he'll explain everything you need to know. So I have this folder over to the side called Carburetor, and this is our package. And it's named after what's called the namespace. So it doesn't have to be exactly the same as the package name. So for example, discord.py uses Discord as the namespace, not discord.py. But this name is how you import it. So in this case, it would be, import Carburetor or import Carburetor CBR, or from Carburetor import this, that, and the other. In the same way that it would be, import NumPy or import Pandas. The NumPy and Pandas folders in those instances would be called NumPy and Pandas. So make sure that the namespace is at least related to the package in some description. And inside that, you need an init.py file or dunder-init.py file. So that's 2 underscores either side. And this is just here. It doesn't have to have anything in it, but it's just here to tell Python that this is a package and should be treated as such. In here, I just have a function. You can put functions in here, and it will just be, if you did from Carburetor import add, you'd be importing this function here. But you can, do all sorts of stuff in the init. Over here, we also have a dunder main. Now, this is entirely optional, but this is more for loading as a module using the CLI, and I'll show that off a little bit later. But you can just have something simple like this. A simple print statement with some lyrics to a song. I'm not really sure what it is. I've just kind of seen it around the internet a lot. So yeah, it's also worth noting that you can have a single file package by doing, in this case, carburetor.py, and then you don't have to have a folder at all. But that's only really useful for small packages, ironically like this one, because it is just the one file to do it. But it will work exactly the same, which is kind of cool. So first things first, we need to let's create a README first. A README is always good to have, and this is actually useful to the tutorial. I should say also this is going to be kind of a lot of copy pasting just to keep the time down, but I will explain everything as we go. So I've just got some basic, README stuff in here. Some more lyrics. I keep seeing these around. I don't know where they're coming from. But yeah, this is a test package for a video tutorial. Just a little description as you would do your README. I'm sure everyone knows what they are. Next up, we are going to have our pyproject.toml file. macOS, come on, play with me here. And we're going to copy this and put that in here. So you can have other stuff in your pyproject.toml as well. This is mainly for tool configurations. So if you had something like Black or ISort installed, then you could configure them in here. There are other ways, but I generally like to configure everything in pyproject.toml. If you use Poetry, you'll also be particularly familiar with this file. But in this case, we just want to have a build system that requires setup tools. And I'm not sure if greater than or equal to 42 is the best thing to have anymore. But I believe version 42 changed something. and I'm pretty sure this came straight from the PyPI documentation, but you can probably put a future version there, it'd be fine. And you need wheel as well. And this build backend, setup-tools.build meta, it just tells the tool we're going to be using to build our Python package how to build it. You don't really need to understand what it does per se. But yeah, that is our pyproject.toml file. Next, I'm going to have our setup.py file, and this is where the vast majority of our time in this video is going to be spent. So there's quite a lot in here. We are going to type this one out. So first we're going to import pathlib. And we're also going to import setup tools. And then we're going to have setup tools.setup. And in here, as you can see from the tooltip there is quite a lot of things we can do. And I am going to be talking about quite a few of them because a lot of them are very useful. So we're going to start with the name, which is just the name of the package. Now I tend to put the name of the namespace here just to be kind of uniform, I suppose. Then you have the version. So in this case, it's just going to be version 0.1.0. You can put anything in there you like. So long as it conforms to PEP. Oh, I'm going to get this wrong on only 449. Might be 459. I'll put it on screen. There is a PEP that defines version kind of schematics or version semantics that you have to follow. And if you don't follow those, then your package won't get accepted. So do make sure you look at that. Then you have your brief description, which is the one-line thing. Now I'll show you real quick. So analytics is one of my projects that I put on the Python package index, and the brief description is this bit here. So it's this kind of one-line introduction, and it also appears here as well. So I'm just going to put brief description for this, just so we can differentiate it from the long description. And the long description is, where is it? Here it is this bit down here. And this will generally be your README. So to do that, we can do pathlib.path readme.md.read text, and that will read that file and set it as the long description. However, because it's markdown, we do actually need to tell setup tools that it's markdown. So we can do a long description content type, and we can set this as text markdown. Obviously, if your README is in RST format, then you'll need to specify that. If it's in HTML format, you'll need to specify that, etc., etc. But mine is in markdown, so we do that. Next is the URL. And I will say at this point, it doesn't actually matter what order you do these things in. And a lot of them are optional. So these kind of 4 or 5 things at the top, these are sort of necessary. It won't shout at you if the description and long description aren't there, but you generally want them. Everything else is kind of optional from this point in, but generally very useful. So we have a URL. So this is kind of just, a URL for yourself. Generally speaking, a lot of the time, this is just the link to your source code, though I'm just going to use my website for example's sake. Then you have your author, so that'll be your author name. And then you have your author email, so this will be your author email address. So I'm going to use my business email address here. Any business inquiries, do feel free to get in touch. Then we have our license, and this isn't the full license, this is just the name of the license. So in this case, we're going to use the unlicensed, but you can put obviously any license you want in there. Next up is, we'll do the project URLs next. Project URLs, and these are these down here. So where it says project links, so where on mine I have the homepage, the bug tracker, changelog, CI, documentation, source. These are all set in here. So for example, you could have, I'm just going to actually copy paste this one. You can have something like this, where you have your documentation is this URL. This URL doesn't exist. I'm just putting it here for example's sake. And the source, you could have it something like this. Again, it might be the same as URL, but it's good to have it here. This also doesn't exist at the moment. I might put this on GitHub. I haven't decided yet. So watch this space. If you really want it on there, then leave a comment and I'll put it on there. But yeah, these will go, I keep going that way. These will go here. Next up, we have our classifiers. Now these are, if I just bring them up, are sort of like tags in a way. Oops. Oh, go away. There we go. I don't know what was up with that. So these are tags. So you can have as many tags as you want. And they are basically like little things to say, well, they're descriptors, I guess. They tell the users what state your project is in, whether it's in planning or alpha or production. It tells you what environment they expect to use. It tells you what framework they're in, intended audience, license, natural language, operating system, programming languages, topics, all sorts. It tells you a lot of stuff. And as I said, you can have as many as you want, so it's good to put on as many relevant ones as you can, because you can actually like filter by classifiers. So it's just good to have them for discoverability's sake. I'm going to have just a simple list here. So we're going to say that our development status is in alpha. I'm going to say that our intended audience are developers. So this is probably some sort of tool to help with coding, like Black Rice or something like that. Then we're going to specify our programming language to be 3.10 and 3.11 compatible. And then we're going to say that the topic it's just a utility. It's something to help out. And you can be as detailed or as undetailed as you want to be with this. It's really up to you. Then we're going to have Python requires. And we're going to set this to greater than or equal to 3.10 and less than 3.11. Now it's less than 3.12. Because we support both Python 3.10 and Python 3.11 as we specified in our classifiers. It is important that this is accurate because pip does actually check against this. So if this is wrong, then it's not going to be installed on versions you want it to be installed on. So make sure this is correct. I used to have checks near the top. Well, I actually still do, but I don't really know if you need them because of this. But yeah, just do make sure this is correct. A lot of libraries don't actually have this less than, and that can cause compatibility problems when you then try and install it. So, say like TensorFlow or Pandas or something, if you install it on Python 3.12, it's not going to work on there at the moment. And it will try because they haven't specified this, and it will break. So just keep that in mind. We're then going to have install requires. And these are your dependencies. So you can have requests as an example, and you can have like pandas greater than or equal to 2.0. So you can have requests. So this will take any version of requests, but it will only accept pandas version 2.0 or higher. And again, you can have as many of these as you want. You can pass requirements.txt files if you want. That's what I do. But as I said, I'm keeping this simple, so I'm not going to do that in this video explicitly. On top of a series of required dependencies, we can also supply a series of optional dependencies as well, using things called extras. And we can provide these using extras require. And this is a dictionary of the extra, identifier. So in this case, we'll use XL. And a list of dependencies that you need when supplying that extra. So in this case, we want to use OpenPyXL because OpenPyXL provides a mechanism of working with Excel spreadsheets. And that would be if the user were to do something like this. So we now install the Cobra package with Excel support as well. So not all Python packages are going to need this, but especially some to do with data. If you want to have, your Excel dependencies, for example, or the ability to write to a pandas, but you don't necessarily want to install pandas by default because a lot of people probably won't use it. Then you can use it for these things. Discord.py is a kind of a channel relevant example per se. Had the voice extra, which installed extra libraries to do with voice compatibility and stuff like that. So the final few things I want to talk about are the packages one, which is just setuptools.find packages, not fund packages. That's very different. That's more an NPM thing. And include package data, which equals true. This include package data is technically optional, though I've had problems. It defaults to false, and I've had problems if this is set as false. So I always set it as true, and it seems to fix everything. And those are kind of the two final little things. There is one more other thing that I want to talk about, but this is only really applicable if you're writing a command line interface application, and that would be the entry points. And you can define a series of entry points. I don't know what the other ones are other than console scripts, but console scripts are your CLI programs. And then you provide the command itself. So let's say, just Carbura. And then you provide the function that it's going to run. So Carbura dot, and we're going to have to actually write this, I think. But say Carbura.cli :main. And then if we were to go into the Carbura, create a CLI.py, and then quickly do a main, and then print, this is the CLI. When we install, or when we pip install our package locally, if we were to run the Carbura command in the shell, then we would get this output in return, which is actually what we're going to do now. So to install your pip package locally, what you can do is pip install -e. Oh, actually, there's one more thing we need to talk about before we do that. I'm getting ahead of myself again. We need to do, well, I suppose this is an optional file, so I can sort of get away with forgetting about it, but this is the manifest.in file. And there are a few defaults when it comes to the manifest.in file, but it is always good to specify your own just in case. And we're going to do graft Carbura. So the graft is essentially include directory. So this will include everything in this directory here. And then we have our include, which is just include file. And we want to include our pyproject.toml. We also want to include our setup.py. Not setup.pyproject. And then we want to global exclude star.py cod. So in certain instances, you would want to include additional files if there's like any additional configuration files, perhaps. The global exclude here is just excluding any temporary files. So the PyC, PyO, and PyD files is what this means. PyC is your PyCache, PyO is your PyObject, PyD I actually don't know. I don't think I've ever seen a PyD file. But you see a lot of this cod in like git ignores and stuff, in automatically generated ones. You do tend to see this pattern a lot, so I just tend to roll with it. If anyone does know what a PyD file is, let me know, because I've always wondered and I've never bothered to look it up. But now that we've done that, we are actually going to install our library locally. So we can do that using pip install -e dot, and -e stands for editable. So it installs it kind of in place, I guess. It installs it in such a way that if you make edits to these files, then the pip installed version will react to it. If you just do pip install dot, and then if you want to make a change to any of these files, when you try to run, say, the Carbura command, it wouldn't actually pick up the changes. So make sure to type -e. And the dot, it's just your local directory. In setup, as you've provided this setup-tools.find packages, it will automatically find this one for you, because it just knows pip is not. How is pip not found? Oh, goodness. Hang on a second. Okay, so now I've restarted PyM because it was being annoying. This should work. Hey, it worked this time. Yeah, I don't really know what happened there. But as you can see, it is installing all of our stuff. It's also installing all of our dependencies as well. So it's installed pandas. It's installed, I forget which other one we had. It was request. Yeah, there we go. And if we were to do our pip install -e dot, and then this is going to have to be quotes because it's ZSH, extras, not extras, that's not what I did at all. It was XL. You can see that it will now go ahead and install OpenPyXL as well. See, OpenPyXL wasn't installed before because we didn't supply the XL extra, but now that we did, it's installed it. Woo. So now that we know how to install it locally, I'm going to show you how to build it and push it to PyPI now. We are specific. What is going on here? Why is there two? Okay, that was weird. We're specifically going to be pushing to the test PyPI. I keep saying PyPI, I just realized. It's PyPI, I got to remember that. But yeah, we're going to be pushing to the test repository because I don't really want to be putting a tutorial on the main one, but the process is exactly the same for pushing to the main one, so it's fine. So we're first going to start by doing pip install build. This might actually already be installed. It's not installed by default. Oh no, it wasn't installed. Oh, there's build 1.0.0. I think that's new. Fancy that. So we're going to do py-m build. And this will now build our environment. One thing I should have pointed out is that when you did pip install -e, it installed this carbo.egg info, which just has various. I'm not sure why it's called an egg really. Maybe snake egg or something for Python. I don't know. That seems tenuous. But yeah, this just includes a lot of stuff you can look through. And now that we've built our thing, it also has a dist with our py3-none-ne.wheel and .target.gz. Ignore the fact this is now version 0.2. I had some issues doing this before. This is actually not my first take at this bit. So it's 0.2 and it's fine. Also ignore when we install it from the repository later. It's not going to install any of our dependencies. Ignore that as well. That's the problem with the test repository, because when you install stuff in the test repository, if your requirements or if your dependencies don't update their test repositories, it's not actually going to install, it's going to error, which is a bit annoying. You won't have that problem with the main repo, but for the sake of, again, I don't want to push a test repo to the live repository particularly. So we're having to make do. This is the fun with the test. You should use the test the first time you push something up, just to make sure that everything looks right, because if you push something to the main one, then you can't actually go back and change it. You have to push another version, and that just looks weird. People will judge you, and if they don't, I will do it for them. So make sure we don't make that mistake. But now that we've built it, we can now push it to the repository. And to do that, we need a library called Twine. So we're going to do pip install Twine. There is also a way to do this using GitHub Actions, but I'm actually going to cover that in a different video. I want to do a separate video on GitHub Actions. I've been meaning to for a while, and I think that would be a good example of a workflow. So I'm going to save that for that. Also, so I'm not overcomplicating this video. So we're going to do py-m twine. And in this case, we're going to do repository test PyPI dist/star. If you're pushing to the main repository, so if you've already done it to test one, everything looks fine, and you want to push it to the main one for real, you would omit everything highlighted completely. The default repository is the main one, so you don't need to worry about that. Press that. And then, oh, that's the wrong command. I need to do twine upload. I'm sure it used to be just twine, but maybe I was wrong about that. Now we need our username, and you don't necessarily want to put in your PyPI username and password, because you can get tokens from the admin console, and then you can pass token with, I should say dunder token as your username, and then I'm going to copy paste this token from this other window into here, and I believe it won't show. There you go, so it's there, and it's uploading, and it's there, and you get a URL, and if we go to that URL, if we open it, it should open on the screen. It does. That's good. And there we go. Our library is available on the Python package index. And here are my previous versions. Here are my previous attempts that I made. So you have this release history here. You have your project links, so your homepage, your documentation, and your source. The source one probably won't work. This one will. The homepage one will work. It will take you to my actual website that you can go to. Woohoo. The other two don't though. You don't have your license information, author information, your requires information, your maintainers, and you have your various classifiers that appear down here. You also have your brief description up here. So this is the, the one line bit, and then your main README is inside this project description bit, which is pretty cool. Now I'm going to copy this command here, and I'm actually going to pip uninstall. Let's see if this works. Do it like that. There we go, that did work. And now if we paste that in here, so pip install -i, and then we're getting it from the test repository, we should be able to collect it. And as you can see, it's not installing our requirements because I took them out because of conflicts, but we actually managed to install our library through test PyPI. And if I were to do our command, this is the CLI. It all works. And that is everything you need to know about creating a package on the Python package index. If you like this video, make sure to leave a like to let me know, and maybe subscribe. The rise of AI in the last few years has brought about some incredible technological achievements. But the thing is, these AIs only know so much. What if you could teach an AI whatever you wanted and then be able to use that model later on? Now, what if I told you that was a reality? Because with Gradient, you can do that. Gradient is a platform that allows you to easily fine-tune existing base models using a very simple API. So they provide the base models for you, they train them using their own data sets, and then you can provide your own data and perform something called fine-tuning on top of that. Fine-tuning is a concept in AI that has existed for a long time, and it involves taking a standard base model that's already been trained on a very large data set with a very general overview of data, and fine-tuning it to specialize it to a particular thing, or just to be able to teach it more things on top of that. So one way you can think of it is by thinking of a school. You go to school and you learn a very broad range of subjects. But as the years go on and you go into higher education, you narrow the subjects that you take down to specialize in what you want to do. So for example, I did subjects in computing and maths and ditched all the others. And this is sort of what fine-tuning is. So you have the base data and you're giving it more specific data to fine-tune it or specialize it to perform a particular task in a particular way, or to, obtain knowledge that it didn't have previously. On top of being able to fine-tune LLMs, Gradient also provides a few other benefits that I want to talk about very quickly. So the first of which is that they handle all the infrastructure for you. Everything's done in an API, and you send requests to their AI cloud, which handles all the training, all the running, all the querying, everything. And that's all possible with zero latency and per token pricing. And Gradient is the only company to be able to do that. They're also very big on open source. So all the base models that they have are open source. All the fine-tuned models that you create are open source, so you can go in and have a look at them all you want. And it also means that you can own what you create. And because of that, you can modify or remove it whenever you want, providing you full control over what you create. So now I'm going to show you how to actually use Gradient to fine-tune LLMs. So first, you'll need to create an account, so you can come to gradient.ai and click this sign up button. I already have an account, so I'm just going to log in. And you can see you get taken to this workspace page. Now, I already have a workspace. You'll be prompted to create a new one, but you'll need to create a workspace and make a note of this workspace ID. After that, you'll need to go to account up here, click access tokens, and generate a new token. I'm not going to create one on the video because I already have one, and I am going to be revoking all access tokens I show on this video before it goes live, so don't even think about it. But once you've done that, you can go back over here into your codes editor. You can create a .m file up here and put in your gradient access token as such and your gradient workspace ID as such. And then we can load them later down the line once we actually start training and running our models. So first, you will want to pip install gradient AI. And then we also want to install python.env as well. So Gradient AI is the Python SDK that Gradient provides. They do have an API, just a raw API that you can use if you want. They do also have a command line interface tool, and they do have, I believe, a Node.js API or SDK as well. So they have a few options, but I'm going to be doing this in Python, obviously. And then our python.env just allows us to load various things in this .env file. So we can do that. And in this video, I'm going to be showing you how to do that with Gradient. So first, you'll need to create an account. So you can come to gradient.ai and click this sign up button. I already have an account, so I'm just going to log in. And you can see you get taken to this workspace page. Now, I already have a workspace. You'll be prompted to create a new one. But you'll need to create a workspace and make a note of this workspace ID. After that, you'll need to go to account up here, click access tokens, and generate a new token. I'm not going to create one on the video because I already have one, and I am going to be revoking all access tokens I show on this video before it goes live, so don't even think about it. But once you've done that, you can go back over here into your codes editor. You can create a .m file up here and put in your gradient access token as such, and your gradient workspace ID as such. And then we can load them later down the line once we actually start training and running our models. So first, you will want to pip install Gradient AI, and then we also want to install Python.env as well. So Gradient AI is the Python SDK that Gradient provides. They do have an API, just a raw API that you can use if you want. They do also have a command line interface tool, and they do have, I believe, a Node.js API or SDK as well. So they have a few options, but I'm going to be doing this in Python, obviously. And then our Python.env just allows us to load various things in this .env file. So we can do that, and I already have everything installed, so it's not going to install anything new. And then we are going to create a new file called run.py. And I'm just going to show you first how to, use the Gradient client that they provide to create a model using the base model and query it using certain things before we get into any of the fine-tuning stuff. So if we do from.env import load.env and from Gradient AI import gradient, and this is our client. If you then do if name double equals main, we do our load.env, so we just call that, and that loads everything in this .env into environment variables. And then we can do with gradient as client. You can, if you don't want to use environment variables, you can provide the access token and the workspace ID into the client itself. But it also supports using environment variables, and all the examples in the documentation go down that road. So I reckon it's probably the better way to go. From there, we can simply create a model, and we can do that using client.get base model. And we need a base model slug. Now, to get access to the base model slug, we go back to the website, and if I just go to the home page, and then if I just go to it through here, and then the docs, guides, and then models, and if I zoom in, this is where we can find out what models Gradient currently supports. So it supports 3. It supports the Bloom 560, the Llama 2, and the News Hermes Llama 2, which is a fine-tuned version of the Llama 2. And we have these slug IDs down here, and these are what you need to pass to that function. So if you want to use the Bloom 560 model, you'd pass this. If you want to use the Llama 2 7 billion parameters, you'd pass this. If you want to use the fine-tuned version with 13 billion parameters, which is the one that we're going to be using, you want to pass in this. There's also a few extra models that will be supported in the future, including one with 70 billion parameters, which is pretty crazy. So that's actually very exciting. But for now, we're going to just copy paste News Hermes 2 or Naus. No, I'm not even sure how you pronounce that. I don't even know if I'm pronouncing it correct. I'm going to continue calling it News Hermes, and people can correct me in the comments if they want to. And then we're going to print loaded model with ID, and we're going to pass the model.id, and then we're just going to use a string representation with that. And then we're going to create a very simple command line interface to be able to query the model. So we can do while query walrus operator import or input, sorry. So each line will have an input, and if we actually provide something to that input, it will do, it will, continue on. If we don't provide anything, if we just leave it blank, it will exit out, but you can just use Control-C. We'll do completion equals model.complete, and then we want to provide the query, and you want to provide this if you use one of the Lambda, if you use one of the Llama models, you'll want to use kind of the Llama template, which I'll talk a little bit more about later. But the general idea is that you have an instruction, which will be the query, and then a double new line, and then you have triple hash response, and then the AI will be, tasked with filling it out from there. So this is the recommended way of doing things in Llama. You don't have to do it, but it's just the way that it wants to. And then we are actually going to specify a max generated token count. We're going to set it to 200 for now. I believe the default is 100 and the max is 500. So And then we're going to print completion dot generated output end equals, and then that. And then if we do pyrun.py, so we can see that we've loaded a model with the ID. This is just the idea of it. And then we can pass a question. So what's the biggest planet in the solar system if I could type? And you'll see once it gets back, obviously these AIs take a little bit, but they're not actually super slow. That was very quick. Jupiter is the biggest planet in the solar system, which is correct. It knows what Jupiter is. That is good to know. What if I asked it about myself? Cabra YouTube channel. Now, OpenAI's ChatGPT doesn't know who I am, and Llama 2 by default also doesn't know who I am. It has absolutely no idea. It tries to guess, and it will normally say one of two things. Yeah, so it says Cabra is a YouTube channel that focuses on creating content related to cars and automotive lifestyle, which is not true. That channel does not exist. However, that's not really a problem because we can just teach it by fine-tuning. So that's what I'm going to do now. I'm actually going to turn that off just in case it does anything random. So I'm going to create a file called train.py, and then we're going to import JSON. We're also going to from.env import load.env again, and then we're going to from gradient AI import gradient, and then we are going to, that's it actually, we just need those three. And then we're going to set a number of epochs, and we're going to set that to 5 for now. And then we have our run guard with gradient. Oh, we need to load.env actually to load our environment. And then we do the same thing with gradient as client. So anything you want to do with gradient, you would start with that line. You don't have to use it as a context manager, but it just makes sure that you close the client at the end. And then we once again are going to supply or say to get the base model, and then our base model slug is going to be news Hermes 2 because that's the one we want to fine tune. However, this time we want to create an adapter. And we're going to do that using model.createModelAdapter. And then we can give it a custom name. So I'm going to call it Cabra just tutorial, I suppose. And this adapter is what we're going to fine tune. So the model is the base model and the adapter is our fine tune model on top of it. And then we're going to print created adapter with ID and then adapter.id, and this we are going to need to make a note of, so do keep this in mind. And then we have actually a series of samples already here, so if I just get rid of that for a second, we can see that I have a number of inputs. So I have 3 in particular, all in the Llama templating again. So you have the triple hash instruction, and then the question. And I think the space might be optional, but every example I saw had it there, so I daren't risk it. Then we have 2 new lines, and then we have triple hash response, and then a response here. And these are, dict value or key value pairs where the key is always inputs and the value is always, this string. It is then a list of these dictionaries. And you can have it in a JSON file if you want. You can also just have it in a dictionary in the code. I felt it was just easy to put them in here because we can just load them in. So if we do samples.json, and I will quickly say before we go into it, that these samples are intended to teach the bot who I am. So you have who is Cabra, you have what content does Cabra produce, who runs Cabra, and then you have various bits of information. So for example, Cabra is a programming YouTube channel primarily specializing in Python content. And these are, somewhat detailed. They're not super detailed. They'll be sufficient because the model is actually able to learn pretty damn quickly, which is cool. We have samples equals json.load and then f. So that will just load our samples into a dictionary. And then we want to do for epoch in range 1 epochs plus 1 prints fine tuning. And then we will have the epoch it's on. So epoch out of epochs like that. And then we want to do adapter.fine-tune samples equals samples. So this is how you fine-tune a model. It literally is just that one line of code. Of course, you probably do want to do epochs like this because the model will, learn better. If you just do it with one epoch, it's probably not going to learn anything. Just be careful with the number of epochs you provide, as fine-tuning a model still has the overfitting problem that just normally training a model does. So if you provide a number of epochs that's too high, it will start to overfit, and then performance will get worse. Again, so there is kind of a sweet spot. 5 is probably too low, but we're just doing it for example's sake here. And then we just print done to show that the script is done. And then this will train our new model. So if I do pytrain.py like this, so you create an adapter with ID this, and I am actually going to copy paste this because we will need that. Oh, I've just pasted something. I hit the wrong button there. I've totally not been using computers for like 2 decades. Getting Control-C and Control-V confused. But you can see it's fine-tuning. So each of these fine-tuning, it's learning more about what I've told it, which isn't that much. Ideally, you would want more data than this. But again, this is just an example. And it is, if anything, an example just to show you how much progress it can make, even on this limited data, which is actually very cool. While it is training, actually, we can go back and we can tell the model to use, or we can tell our run script to use the model we want. It's done now, so we can just close that and do this. And we want to, instead of using this line of code in our run, we just want to do model equals next, and we want to do a filter and specify lambda m, which is the model object, and then we want to do m.id double equals sys.argv1, and then I'm going to provide sys. I'm essentially just doing this so we can provide the model ID in a command line argument. You don't have to do it this way if you don't want to. And then we want to pass client.list models only base equals false. So if you provide only base equals true, it won't return out any of your custom fine-tuned models. If you provide only base equals false, then it will return all the base models and all the fine-tuned models that your account is associated with. I'm actually going to make sure that's on another line. And then we'll load the model like that, and then we will query it, and then we will see if it's able to work out who I am. So if you do py run.py and then we'll pass that in there, it loads it. And if I say, tell me about the Cabra YouTube channel, it should now be able to work out who I am, or it should at least have a much better idea of who I am once it gets back to me. There we go. So it's come back and it now says that Cabra is a YouTube channel dedicated to teaching Python, which is correct. It also says the channel is run by a software engineer named Alex. It's sort of confusing the information a bit. This sort of thing would indicate that you would probably need maybe a little bit more data or maybe a little bit more training time to actually get there. We are, giving it a very pitiful amount of data, so I'm not surprised it's got a few things wrong. But you can see how much progress it's made in just that data and just that time frame. And this is the power that gradient gives you, and this is the ease that it gives you to do it. Because it is literally just, we've done this in what, like 10 or 15 minutes or something, and we already have a model that is now, it now knows who I am. And the best thing about this is that because these LLMs are all very smart and very powerful, you can get a model, even one of the gradient ones, you can pass this into it and you can tell it to then generate a larger data set based on what you've provided here. And you can get your own model essentially to create the data to train itself. And then it's at that point, it's the self-fulfilling prophecy. And that, that's the power of these AIs. They can do anything you want them to do. And that's just a really simple example of the sort of stuff you can do with fine-tuning LLMs. They have a huge base knowledge already, so they already know a lot of stuff. But you can, as I've shown here, teach them something new. You can also expand their knowledge in a particular field that they may already know. You can kind of specialize them down. to just talk about that. So if you wanted an AI that knew everything you wanted to know about literature or whatever, you could do something with that. You can also, if you really wanted to, train it to talk a particular way. So if you wanted it to talk like your favorite character out of a TV show, then you can do that. You can easily do that just with enough data and enough training time. You can get it to do whatever you want. So the possibilities are pretty much endless. If you like what you've seen here, then make sure to head down to the description. In the last year or so, or especially the last few months, huge focus has been put into multi-core or multi-parallelism in Python because of the work done in 3.12 to get the interpreter's C API out the door, and then more work in 3.13, not only to get the interpreter's Python module out the door, but also no-GIL Python is coming. There's this huge push, huge drive to get multi-parallelism in Python going for many reasons, and there are many peps, and I've done numerous videos talking about all that already. But what I wanted to do is I wanted to look at what we have at the moment. So in 3.12, we still have threading, multiprocessing, and async. Async is very different. I've done a video on async already, but I haven't done any videos on threading and multiprocessing yet. And I did want to kind of have a look at those, have a look at the interfaces, have a look at the speeds, kind of see if we can figure out where the problems in these current implementations lie. And to do that, I'm going to show you how to do threading, how to do multiprocessing, and I'm also going to do some nice little performance benchmarking for you. So first I'm going to do threading. So we're going to import time for just for benchmarking purposes. We're going to from threading import lock and thread. We'll come to locking later, but for now we'll just leave it as thread. And then we want to do from URL lib.request import URL open. This will just be for some IO stuff that I'll do later on. So we're going to define a function called do CPU work. And I'm not going to bother with type ins. And this is just going to do some CPU work. So for I in range 20,000, do 2 to the power of I. And then we have if name equals main. Have threads equals. Actually, no. Let's not do it threads for now. I want to show you how long it takes to run through 10 iterations of this serially, and then I'm going to show you how long it takes to run 10 iterations of this in a thread. So we're going to do start equals time.perf counter, which I realized was a thing not too long ago, embarrassingly recently, I think. And for underscore in range 10, and then we're going to just do CPU work. So that's just going to do all the CPU work 10 times sequentially. And we're going to do print. I want to do time.perf counter minus start. And then we're going to do some fancy string formatting to bring it to 2 decimal places, and then we're going to output it in a number of seconds. So if I do pythread, if my terminal wants to respond, there we go, that was weird. So I do that now, so this is just doing it serially. It takes 3.8 seconds to do that twice. Now bearing in mind this is Python 3.12, and I am recording at the moment, which I have realized does slow things down sometimes. But when I was doing this earlier, I was getting maybe like 3.5, 3.6 seconds to do that. If we do that again, just for the sake of consistency, this isn't as scientific as I perhaps normally do it, but this is fine for now. So you can say, it's doing about 3.8 seconds. So one thing you could do if you wanted to speed it up, or one thing you might try to do if you wanted to speed it up, was to do multi-threading. So we could do threads equal, not feeds, threads equals that. And then for I in range 10, t equals thread target, and then we pass in the callable. And then we do threads.append t, and then t.start. So what we're doing here is we're creating a new thread, and we're giving this callable as a target. So this thread will run that function. If you give it a function that doesn't end, the thread will just keep doing it. Like if you have, I don't know, say you had a game and you had one thread doing the music, one thread doing the graphics, and one thread doing the calculations. If you had 3, in theory, infinitely running functions, and each thread would just be busy doing that. This is the same thing, it's just obviously this will end. And then when it does end, in threads, we need to join. We need the thread to join. So I believe this then joins the thread back into the main, into the main thread, and I believe it returns any arguments and that and all that stuff. So if we did that, we ran it again, we would see that it takes 3.74 seconds. So that's what, 5/100ths of a second faster than if we were to run it serially, and we've done 3.76 seconds. Now, if you've seen my video on the GIL, you'll know why that is. It's because essentially threads, when it comes to CPU intensive work, tend to do things pretty serially. So if you haven't seen that video, I would recommend going and watching that, because it will give a more detailed explanation of why threading isn't any faster than doing it serially. But in that video, I did explain, or at least the presentation. I'm not sure how much of an emphasis I put on this, but the presentation that was my source for that part of the video made a point that I/O bound work, so things where you're waiting for the operating system to load a file, or if you're sending a network request off and you're waiting for it to come back, threads don't get locked up anywhere near as hard when doing I/O bound work. And I'm going to show you that is the case. So if we do I/O work, and then if we just do URL open, and then we do HTTPS, oh god, what am I doing? YouTube.com. We pass in I/O work as our target. If we were to then do this serially, so if I just comment all this out, if I comment all this out like that, and then do I/O work, and then run that. So this is doing all the requests serially. So we can see it takes 3.27 seconds to access the YouTube main page 10 times. If we did it in a thread, or if we did it in threads, like so, it takes 0.49 seconds. So you see in this instance, threading actually had a huge performance benefit. And that's because it's not doing any CPU work. It's, a lot of the stuff it's doing is just waiting for a response to come back, or in the case of file I/O, it's waiting for the file to be opened. It's not actually doing anything. It's when things get busy that threads get tied up. Before we move on from threading, I do want to quickly talk about locks, because locks are quite an important part of threading. So if I were to do something like print and then start and then print end, and here we run this again, we can see that each thread starts, and then all the threads end before, all the threads start before any of them end. That's what I'm trying to say. So you can see that this is how the threads are working. In this case, it's fine. We don't need to worry about that. But there are instances, especially when it comes to CPU bound work, where things may need to be done in a certain order. And of course, you may end up in race conditions if you don't do things properly. And one way to get around it is by using a lock. So we can create a lock, and we need to create a kind of a global object. Because if you create a lock for every single thread, then they're all just going to use their own lock and it's not going to do anything. So you need to create a global lock, and then you could just use the context manager. So with lock, you can do that. So the thread will acquire the lock, and the lock, I think, will just know what thread is doing. It's all a bit magic what goes on here, I think. So the thread, or the lock will know which thread has acquired the lock, and then it will run. And then once you exit out of the context manager, the lock will release, and another thread will be able to grab it. Do this again, we can see that we're essentially just running it serially now. And it completes in 2.99 seconds, where before it took 3.2 seconds. Okay, so it's still a little bit quicker than doing it serially somehow. But you can see with the lock, it sort of makes it run serially at that point. But now that we've talked a little bit about threading, I want to talk about multiprocessing. And believe it or not, the interface is pretty much the same. So the only difference you need is from multiprocessing import process. And then you'd, have different naming conventions. You could even call these workers and get away with calling it exactly the same thing if you really wanted to. But you have your process, you have a target, which in this case, I'm going to change that back to CPU work just so we can see it go. P.start, and then for P in process is P.join once it's all over. And then, so if I run this, we can see that it runs a lot faster. So we're now running our CPU. So this is our CPU work. So if you remember with threading, this still took like 3.8 seconds. With multiprocessing, it can take 0.63 seconds because we're now actually using multiple cores. And in the case of my M1, we're using 10 cores, so we are using every single core this thing has. And every single core is doing the work at the same time, which is not the case in threading because it doesn't have to thread switch anywhere near as much. Now you may be wondering, why not just use multiprocesses all the time? And this is where this benchmark script comes in. So this was actually written by a friend of mine a little while ago. I have added some extra stuff and I've modified one or two things to make it work better in my case. So I've added this IO work bit. I've added something, I've added the callable. But this was a script that he wrote that he's allowed me to use. And it essentially compares threading versus multiprocessing really well in terms of both speed and memory usage as well. So we have 4 test cases down here. The first of which is a thread doing CPU work. Second is multiprocessing doing CPU work. Third is a thread doing IO work. And the fourth is multiprocessing doing IO work. And if we run this now, take a little while. The CPU work is a bit more intensive. You can see it's a little bit more like comprehensive as well. So the CPU work is a little bit more flashy. The IO work fetches more than one URL, so it's a little bit clearer about what it's doing. Everything's done. So if I move this up, once everything's done, it outputs this nice little well, I was going to say table. It's not quite a table, but it's a nice block of information with the methods. So in this case, we use the thread, the callable, completion time, the current memory usage, and the peak memory usage. And you can see when it comes to CPU bound work that threads are a lot slower. So a thread took 8.17 seconds, multiprocessing took 0.24 seconds, but the memory usage was about 10 times higher on multiprocessing. And that's strangely correlative, you may think, to the fact that we've spawned 10 processes. And that's because a multiprocessing, every time a process is spawned, it's a brand new Python process. Like it's almost like starting up 10 scripts manually. And while that does mean that, one process can use one core each, and as such you get true multi-core parallelism because you are utilizing all your cores, it does mean that you have the memory consumption that goes with having 10 separate processes as opposed to just having 10 threads with one global state, one loaded interpreter, etc., etc. The interesting results to me is that the IO work, multiprocessing, was actually faster in these benchmarks and significantly less memory consuming, which I'm pretty sure it was the other way around when I did this off camera. And I did run the results again, and it's come out with the same thing. So I will run the results off camera to see if I get the same thing, to see if maybe the recording is like screwing something up somewhere. But I am sure that the threading not only was faster, but was less memory consuming as well. I think that's the right term. I've said that twice. I've doubted myself both times, so I don't know. But yeah, the threading, at the very least, is a lot closer to the multiprocessing than it was before, even though the memory consumption, I think, is it's just wild. I think it's wrong. I think these benchmarks are wrong. But I will confirm that once I stop recording, and I will let you know. If these are right, the multiprocessing perhaps is always the way to go. But when the interpreters come in Python 3.13, well, they're already here in 3.12, but the Python module doesn't come in until 3.13, you'll have sort of the benefits of both. So you'll have multiple interpreters loaded, but you won't have multiple Python processes loaded. So it would be like threading in that you only have a single process, but it would be like multiprocessing in the sense that you have multiple interpreters. And this will allow you, so each interpreter will have one core, and each interpreter will also have a single GIL, or its own GIL rather than a shared GIL across the whole lot, which means that every interpreter will be able to properly utilize multiple cores, and you'll only need one process to do it. The only downside is that the implementation is a lot different. So where in here, for example, the multiprocess is probably a better example, you have this process object and you give it a target, and then you can define all your things up here. And it's a pretty clean interface actually. And this has been around since Python 2. Whatever. And it's basically unchanged since then. Maybe a few things have been added, a few things in the back end have been optimized. But I was looking at the old Python 2 docs because I wanted to see if multiprocessing had a really jank implementation before, and it doesn't. It was always really clean. It still is really clean, and the interpreter's implementation is a bit weird. So we'll have to see how that goes, but I'll talk about that more when it actually comes out. If you like the video, then make sure to leave a like to let me know and subscribe. For those of you that have never heard of JWTs before, it stands for JSON Web Tokens, and they are, as it says here, an open industry standard method for representing claims securely between two parties. Or, in other words, it's a way to securely send JSON objects from one place to another. And JWTs can be very complicated. I'm going to be running you through a little bit about JWTs, kind of just all you need to know. I'm not going to be talking about absolutely everything because I'll be here for hours. But after I've done that, I'm going to be showing you how to encode and decode them in Python. A good place to start with JWTs is jwt.io. This website provides a nice little kind of representation down here of what a JWT is. So this is just a JWT string and what exactly the JWT contains. So there are 3 sections in a JWT, all of which are base64 encoded and combined into a single string separated by dots. So you can see a dot here and a dot here. This first section contains the headers. So this type is, oh bloody hell. Oh, yeah, this website's a bit weird sometimes. But this type parameter is optional. The only one you absolutely need is this alg parameter, and this controls the algorithm used to sign and encrypt the token. And there are plenty to choose from, so you can actually choose from a list up here. So you have all these down here. HS256 seems to be used quite a lot. However, Google, of course being Google, uses RS256, and my experience of using JWTs comes from Google, and as such I'm going to be using this. The only thing that changes is the actual verification signature itself. The rest of the JWT is all the same, and as far as I can tell, encoding and decoding is a relatively similar process, or at the very least the libraries I'm using will be able to handle those other algorithms. But this is just what I know, so this is what I'm going to be teaching you about. If you're planning to use Google's OpenID Connect, then RS256 is the one you'll need to know. And RS256 seems to be somewhat left out in videos and Stack Overflow answers especially. So it's nice to give it a bit of a light and hopefully help out other people who are struggling with RS256 like I was not too long ago. The second part in purple is the payloads. This is the actual JSON data that you want to send. In this particular JWT, we've stored the sub, the name, admin, and IAT. You can store whatever you want in a JWT. There are absolutely no restrictions whatsoever. However, there are a few rules if you want to use them for certain things. So if you want to use them in OpenID Connect, for example, there are certain things. And there's a specific keyword, or there's a specific key, I guess, that JWTs look for, or JWT libraries tend to look for, to check whether a key has expired. There's a specific key that you need to provide for that, as per the standard. But I'll talk about that a little bit more near the end of the video. And then this blue bit down here, we have the verification signature. So for RS256, it is an RSA SHA-256, and then we have, your base 64 URL encode, public key and private key. There are 2 other things that we need to at least be aware of before we move on. The first is a JWS, which is a JSON Web Signature, which is used to kind of sign and verify the token. We don't need to know a huge amount about that because the libraries I'm going to be showing you take care of that for us. But just in case you run into an error regarding JWSs, then you know roughly what's going wrong. The second thing we need to know is JWK, and I'm going to be talking about that now because we need to encode a JWT, or we're going to encode a JWT. So if you come over to our code editor, we have a script ready for us. And we will want to do, when my terminal decides to load, there we go, we want to do pip install JWCrypto and JWT. So JWCrypto is a library that's good for encoding JWTs. We're not going to be doing the full encode process with it, but it has utilities in place to help us generate JWKs, and that's what we're going to be using it for. We're going to be doing all our encoding and decoding with the JWT library. A lot of people, if people know about this already, they might be thinking, why aren't you using PyJWT? The answer is I don't like it. I don't like how it works. I can't figure it out for the life of me. I spent ages. The documentation is rubbish. This library is just much easier to use because it supports JWKs out of the box, which is what I wanted for what I was doing at the time. So as you can see, we installed JWT. Where is it? Well, JW Crypto 1.2.14, I think. No, that's not it. That's deprecate. JW Crypto 1.5 and JWT 1.3.1. So what we're using in this video. So the first thing we need to do is need to specify all our imports. So we're going to do from jwcrypto.jwk import JWK, and from JWT import, I'm going all over the place, JWT and JWK from dict. And then we're going to have, that doesn't need to be double spaced, we're going to have a run guard, so we're going to have if name equals main. And then we're going to specify our data that we want to encode. So I'm just going to use the data that was in the example on jwt.io. So we have our sub, our name, our admin, and our IAT. And we're just going to have that as a dictionary. You can load that in from a file, or you can, take that from a request, or, anything you want really. And then we're going to generate a public key and a private key. It'd probably be better actually if we did private key and public key in that order. I suppose it's just a matter of preference. And we're going to create a function called generate keys. And we're going to generate that now. Or we're going to create that now. We're not going to generate it. So we have generate keys. It's not going to take any arguments at all. And then we're going to set our JWK object equals jwk.generate, and then we need to provide a few parameters. So I'm actually going to put each on a new line just so it's a bit easier to read. So we have our key type is RSA. If you're using HS256, and I think you'd put HS or HSA there, maybe. I'm actually not 100% sure. If your size equals 2048, alg equals RS256. If you were using HS256, you would put HS256 in there. We're going to supply our use, which is a signing key. And then we're going to supply our key ID, which can be anything you want, so long as it's a number. And we're just going to supply this as 420 because we're elite on this channel. And actually, I'm not going to bother having it on multiple lines. It all fits on the screen at once, so it's fine. And then we're going to return two things out of this function. So we're going to return. No, I forgot the word then for a second. We're going to return jwk.export private as dict equals true. jwk.export public as dict equals true. These by default export as a JSON string. However, for what we're doing, we actually want it as a dictionary, so we pass this as dict equals true. You could also use json.loads if you wanted to. We're not going to. So if we print private key, and then I guess we'll just do some really horrible debugging and do print public key, just so we can get an idea of what they look like. I might do a pprint actually here. Yeah, I will. Just for the sake of making things a little bit easier to work out. If we run that now, if I could actually type, because my microphone obscures my keyboard, so it is a bit difficult sometimes. So we have these two things here. So we have our arg, d, dp, dq, kid, kt, yn, and then all this, that, and the other. Our private key is a lot larger than our public key. And the public key, when you're using APIs, so if you use the Google API, the public key is the only one you're ever actually going to see. This is probably the most important one to actually know about. So the alg is obviously the algorithm. The n is the public key itself. I believe this to be the base 64 encoded PEM key that we saw here. So that'd be this thing here. The reason I say I believe is because there are a number of caveats to this. If you look at the JWT docs in some cryptography libraries, import an extra octal, and then it gets really complicated. But thankfully, we don't need to deal with that. E is the exponent. This AQAB is base 64 for, I believe, 65537. I got that slightly wrong, but it's, would it be 65? It's either 65535 or 65537. I forget. You have the algorithm, of course. You have the key ID, and you have the key type, and then you have the use in here as well. Now we've generated our keys, we can use them to encode and decode our data. So we're going to start by encoding, and we're going to create a variable called token. Let's say encode data, and then we need to pass the private key, because the private key is used for encoding and the public key is used for decoding. Go up here, provide function called def encode, and then pass the data and then the key. And then before we go any further, we need to come up to the top and we need to do JWT equals JWT. So you can sort of think of this like a client. All the encoding and decoding logic is within an object. I don't really know why, because looking at the source code, it doesn't really look as though it needs to be an object. But it is. It's a design decision that was made, so we live with it. But we just put it on the top level, so it's available in all our functions without having to recreate it every single time, even though it probably doesn't really matter that much. So first we need our JWK back, and we can do JWK from dict key. So this will be our private key. So this will take this dictionary here and turn it into, well, I suppose this is a JWK in and of itself, this dictionary format. It just turns it into a Python representation that the library can use. And then we just need to do return JWT.encode our data with our JWT object using algorithm RS256, because we do need to supply that separately. And then we can also put in some optional headers. So as I said, the algorithm is the only header we need, but if you did want the type header, for example, you could do optional headers and then provide a dict. So it would be type JWT, like, that's a W, not an S, like that. And now you have an encoded JWT with all your data with RS256 encryption with our optional headers in place. And if we print that to the terminal now, we end up with a string that looks very much like this. And if we were to pass this, I think this is the end, including the G, come on. It's exactly 4 lines long in my terminal. That's quite impressive. If we paste that in here, then we can see that's, well, it's pretty much the same because all the data is the same. But we have our type and algorithm here, and then we have our private and public keys down here, and it all works just fine. That was my wallpaper. That's a very autumnal wallpaper I've got at the moment. Yeah. So now we have this token. This is what you could send out across the web to anyone, and because it's base 64 encoded, you don't have to worry about any encoding problems, because everything can do with base 64. And then you just need to have your decoder on the other side, or the client side, or potentially even the server side if you're sending something to a server. And that's what we're going to do now. So we can get rid of this line here. I'm going to scroll down a little bit. And then we're going to have our payload equals decode. And then we're going to be decoding our token using our public key. And this is a very similar function. We take the token, and then we take the key. I still can't type. And then we provide, or we create, a JWK again, JWK from dict key. And this is now taking, we'll see if it's even still on here, it is. So this is now taking the public JWK and using that to decode it. And then we can do a return of JWT.decode token JWK. So decoding something is a lot simpler than encoding it. And if we were to print payload, we will see that we get the payload back as we got it. And we can confirm that for sure by checking that our payload equals data. And it does. We have encoded and decoded successfully a JSON object. So I did want to talk about claims before I finish off this video. I've spent maybe like 10 or 15 minutes trying to find this web page that I found when I was researching this video, and I cannot find it for the life of me. If I do find it, I'll put it in the description. But I wanted to talk about claims and certain specific rules that you should follow when it comes to JWTs. So each of these keys, I've been referring to them as keys throughout this video. They're actually called claims in JWT. So the sub claim or the subject claim, the name claim, the admin claim, and the IAT claim. So some of these are used in certain situations, some of them aren't. So the admin is an example of just one that JWT.io has included in there. That's completely custom, that's not normally there. The subject and, well, I think optionally the name are used in OpenID Connect ID tokens, and an IAT is also used in there as well. Name it can be used in user tokens or IAT tokens. But this gives a little bit of an idea. So you can see the sub claim, for example, claim identifies the principal that is the subject of the JWT, which is basically just a long way of saying it's a unique ID for the JWT. Audience claim, this expiration claim is the one that I wanted to bring a special attention to. The EXP expiration time claim identifies the expiration time on or after which the JWT must not be accepted for processing, and it is specifically EXP. This is what I was saying about with different rules. So if I were to have, say, like EXP is 100 here, and then we try and run the same thing again, we'll actually get an error when trying to decode the JWT, saying that the JWT has expired, because JWT actually checks this expiration for us and will reject it if the expiration has expired. In Google's case, this, and it might be an OpenID Connect specification, I don't know, but expiration is normally whatever the IAT is plus 3600. So this IAT is the Unix timestamp. I can't remember if it's seconds or milliseconds, but it's essentially the Unix time in which the JWT was created. The EXP is always 1 hour after that time. At least one's created to specification. Obviously, custom ones you could put whatever expiration you want on it. The idea is that you don't use JWTs after they've expired, because it's more secure that way. The less time you have to send it around places, the less times it would be sent around places, and so the less opportunities for a hacker or a bad actor to ever actually decode it. So that's the usefulness of an EXP. Obviously, everything is optional. Whatever, you can put whatever in there. But that's a general idea of JWTs and a little bit of an idea of what I was doing in my spare time last week, trying to do JWT stuff for analytics, because I've been wanting to learn about them for some time. And now I've been able to teach all of you as well. If you like this video, make sure to leave a like to let me know, and consider subscribing. Python 3.12 introduced a lot of new functionality. If you want a little overview, then there's the video in the cards up in the top corner. Today I want to talk about the new Itertools.batched function, which is something that was added especially to the Itertools library. It's really useful, and now it exists. I really wonder why it didn't exist before, because it seems very obvious to have. So yeah, I'm not sure it wasn't there before. It is there now, and I'm going to be walking you through what it is, how it does, how it works. Those were words in the right order, definitely. So, so I've already done a video today. Ironically enough, I'm doing this in a batch. How about that? So if I lose my mind, and I do apologize for that. If you found this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like it. If you want to support this channel monetarily, you can do so by becoming a patron or a member. All the information you need is down below in the description. So to start with, we're going to go from Itertools import batched, and I'm just going to show you a very simple example first before we get into something a little bit more comprehensive. So if we just have a list sequence, so 1, 2, 3, 4, 5, 6, 7, and then we print batched, and so we provide the iterable here, and then we provide the number of elements that should be in each batch. So in our case, we're going to do 2, and we do that, we'll see we just get an Itertools.batched object because this is a generator. Much like everything in iterables or in Itertools, it is a generator or an iterator. I suppose it makes sense when you think this is Itertools. If you want to see what it's actually doing, then we can do list batched. It's particularly useful that batched is a generator because it does actually make it really useful for if you've opened a file and you want to do some batch processing on it, or if you've received a message from a socket and you want to do some batch processing on it, and you can do it through that if you want. But if you just do this, and you can see that we have our things in batches of 2. So we have 1, 2, 3, 4, 5, 6, and then we have our final batch over here, which is just a batch of 1. It just puts whatever elements are left at the end of the list in a batch on their own, even if the batch isn't the same size as the rest of it. So do keep in mind that not all batches will be the same size necessarily. But now that we know how this works and what it does, I'm going to show you a more comprehensive example of how it can be used in the real world. So to do that, we need import JSON. We also need import time. And then from URL lib.request, import URL open. And this is just the Python built-in URL lib, essentially. I wouldn't recommend using it in the real world like ever, but it's good for something like this. So one of the things that batched is really useful for is doing some scraping on an API or a web page or whatever that has a rate limit, because you can send a certain number of requests per minute or per second, and then you can sleep for a bit, and then you can send another set of batches and then sleep and then another set. And it's just a bit nicer than having to manage, rate limits for each individual request when you can just do it in a batch. So first we are going to do URL lib.open. I'm actually going to copy paste this because this is largely just setup code for what I want to do. So we have this resp URL open. We access the Python package index API for one of my own packages, and we get a list of all the versions using releases.keys. And then we also get the latest version for something that we're going to be using a little bit later. So if we then do for batch in batched versions, and we're going to batch them in batches of 5. We do for version in batch. There's going to be a lot of nested for statements if you use batch, unfortunately, but there you go. We can do some logging. So we can say checking version. We can make a request, so URL open to, and I'm just going to copy paste this URL because it's quite long. There we go. And then we can do whatever processing we want on that. I made the executive decision to not do any processing as part of this example, just to keep things a little bit simple. But you can do whatever processing you want on that from there. And then at the end, you can do, say, time.sleep, and we'll say 2, for example's sake. I don't think the Python package index API actually has much of a rate limiting thing, or if it is, I think it's fairly generous. But we're just using this as a good example. So now if we run PyScript now, we can see that it's done that batch of 5. They've all come through at once, and then it sleeps for a bit, and they've all come through at once. Then it sleeps a bit, they've all come through at once again, and sleeps a bit. And you can see, it will keep going like this until the end. So say, for example, this PyPI or PyPI, I've got to keep remembering that, API has, say like 10 requests a minute or something. Then you can say batched versions 10 here, and then you can time.sleep 60. And then you've got those 10 requests all in a row, and then you sleep, and then you, get another 10 requests. Rather than having, one request and then maybe sleeping for, would it be 6 seconds? I think it'd be 6 seconds, but I might have got my maths wrong. You get the idea. But the more eagle-eyed among you may have noticed that we actually slept at the end of here. So we got the final 3. I believe these, either these 2 or these 3 are in the final batch. And then we got to the end of the batch, and then we kept sleeping, which we don't need to do. So what we can do, and I should probably actually put some logs here, sleeping for rate limits, ... And we could do if version does not equal latest, then we do our time.sleep. So as version is being set in this for loop, we can actually use it outside of it as well. So this version will always be the last element in a batch. And then we check if it's the latest version, then we know we've come to the end of the list and we don't need to sleep. Unfortunately, that's the only way, because this is a generator, that is the only way of knowing. So if you don't know beforehand, then you don't have a way of knowing in the batch either if it's the last one. But now if we run this again, you can see it sleeps for rate limits, sleeps for rate limits again, sleeps for rate limits again, and it will keep doing this. I've released quite a number of versions of analytics over the years. It's kind of been almost my magnum opus in a way. Unless I count Cabra as a magnum opus, then I'd probably say the channel was the magnum opus. But I'm just filling for time because we're about to get to the end, and you can see it doesn't sleep. So it is just these two. It checks these two, realizes, oh, I'm at the end, and it doesn't actually sleep. So that's a little optimization you can do. But that is the general idea of the batch library in Python. If you have any questions about what you've seen here or any ideas. A little while ago, I did a video on the standard lib module, Functools. It's a really useful module to have. There's a lot of really cool things in it. If you want to see that video, I've done, or there'll be a card in the top corner. Today, I want to focus in more on the caching elements because I did a little bit on the caching in that video, but not a huge amount. And if you use caching properly, then, oh my God, the speedups are ridiculous. At time of recording, I haven't decided whether to state this in the thumbnail or not, but there is the potential to get effectively infinite speedups in Python using this method. I'm going to be showing you one of those situations where the speedups are just ridiculous. Of course, it's only going to speed up a small amount of your program, but especially if you're calling a function with a certain series of parameters a lot, or if you're calling a certain property a lot, and that function is particularly expensive, then caching like this can really help speed your program up enormously. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. If you want to support this channel monetarily, you can do so by becoming a patron or a member. All the information you need is in the description below. So to start, I'm going to be importing Functools. I'm going to be importing cache and LRU cache from Functools. So these are the two types of cache that you can get. Functools, these work on both methods and functions. I'm only going to be showing it on functions today, but they do work on methods just fine. And I'm going to be starting by showing you the normal cache because it's the simpler of the two to use. So you just want to use a decorator like that, and say we have def add x and y. We then print adding, and that needs to be a format string, x and y together. Oh, I can't spell either, my God. Like that. And then we do return just x plus y. If we have if name equals main down here, it's always something you should do. And then we say we print add 1 and 2, and then we say we do that again. We'll see that we only see this logging message once, and that's because it runs the function once to calculate the result, and then stores the result in a cache. And then once you call it again, it does a cache lookup and sees, oh, this is in the cache already, and it just returns the result straight out. The cache is bound to the function parameters. So if we were to do, say in the middle here, if we were to do add 2 and 3 together, you'll see we have one for adding 1 and 2 together, adding 2 and 3 together, but then it doesn't add 1 and 2 together. And of course, it's because if you add 1 and 2 together, you haven't cached the result of adding 2 and 3 together, so that needs to be cached. So that's a particular advantage of caching a function like this over storing the result of a function in a variable name, for example. One other thing to keep in mind is that the order of arguments do matter, even if you used keyword arguments. So if we did add 2 and 1 like this, we will see that it has to compute adding 2 and 1 together, even though we've already done that, because adding 1 and 2 together and adding 2 and 1 together are the same thing. The cache doesn't know it because all it registers is the argument order. If you do something in keyword arguments as well, which actually allows you to kind of have exactly the same function call, just with different argument ordering, it will actually need to recalculate in that instance as well. So do be careful of that. Now we've talked about caching, I want to talk about its slightly more verbose brother or sister, LRU cache. And this can be used just like this or like this. And we're going to say, we're going to have a square function here just to make things different. And we're going to say squaring x, and then we're going to return x to the power of 2. And then we can get rid of all this. And then we can print square 1. And say we squared 2, and then squared 3 as well. And then chose to square 1 after all of that. You'll find that it does pretty much exactly the same thing. So, or at least it looks like it's doing exactly the same thing. There are small differences under the hood. I'll talk about those in a second. But we have squaring 1, squaring 2, squaring 3, and then we have the result of 1 already stored. The main difference between cache and LRU cache is that you can supply a maximum size for the cache. So by default, that's 128. If you provide max size equals none, then it essentially becomes this. It becomes exactly the same as this. So LRU cache is just a cache with a maximum size, and the LRU relates to least recently used. So once the cache is completely filled up, the least recently accessed or least recently used cache will be thrown out. So it's not the oldest, it's the least recently used, which means that if you are calling something from the cache a lot, even if it happened like half an hour before the other thing, that will stay and the other one will go, which is really nice. So if I were to set this as a max size of 3, and actually set it as a max size of 3, and then say, oh bloody hell, say we did this and we set this to 4 and 2, what we'd have is it would square 1, it would square 2, it would square 3, and now the cache is full. So we're grabbing 1 again, and it's all good. And then we're squaring 4. And then the cache needs, so this needs to go into the cache, and then something needs to be thrown out. But because we've squared 1 already, squaring 2 was technically the least recently used from there. So then when we go to square 2, we actually need to square 2 again from scratch because it's not in the cache because it was evicted. So now that we've covered the basics of caching and LRU caching, I want to show you just how powerful caching can be. And there's no better example of that than the Fibonacci sequence. So for those of you that don't know what the Fibonacci sequence is, you start with 0 and then you go to 1, and then each element beyond that is the previous 2 items added together. And there's a little bit of a shortcut here if the number is less than 2. But other than that, you can use recursion to simply just add the previous 2 elements together. And for those of you that know what recursion is, you can probably see where this is going. But I'm going to run this on here, so pyfibonacci.py. It should take about 10 or 11 seconds to run. We're just running it through once, and we're running it to 40. So we're getting the Fibonacci sequence 40 elements in. And you can see it takes 11 seconds to do that without caching. If we then did it with caching, it takes 9 millionths of a second. Now that is about 1.2 million times faster, just with a single line of code. Now, I'm not going to lie, that is absolute clickbait fodder, but I've chosen not to do that because it's a little bit disingenuous to say that caching will make your code millions upon millions of times faster. Sure, it does have the potential to, if the entire program is the Fibonacci sequence. But if you're caching, something in a much wider scale, then it's not going to speed anything else up. It's just going to speed up the things you've cached. Obviously, caching does have its limitations. So anything that is like, well, if you have like a random number, for example, you don't want to generate that. But it is particularly useful if you want to, if you have an expensive function that you're calling with the same parameters over and over again, especially if that function is particularly expensive, because it can save you. I mean, this is just the speed of a dictionary lookup, this 9 millionths of a second, as opposed to the 11 seconds of the computation from before. But again, yeah, this is using recursion, so make it that what you will. But you can see how, it can be infinitely faster using caching as opposed to not in certain situations. On top of using it in functions and methods, you can also use it in properties. So I've just put together, a really weird example here. I couldn't really think of a better one, but it has this cached property here. So from Functools import cache property, and this is both cached and a property, so it's both at once. So if we had a number of a very nice 69, then we can print whether n is prime. And then we can print again whether n is prime. So if you wanted to use it multiple times, obviously. So if we did pi property.py, we can see that it only has to calculate it once, and it calculates that it's false both times, and then it can access it later. So this is particularly useful if you have an expensive thing and you don't really want to have multiple variables or multiple attributes, I should really say, and then you have a method to that you then assign to the attribute. It all gets a bit messy. This helps clean things up just that little bit nicer. So that's everything that I wanted to talk about caching. When comparing Python to other languages, people will tell you a lot of things that Python doesn't have. So they'll say that it doesn't have private class attributes, they'll say it doesn't have strong typing, and a lot of them will say that it doesn't have function and method overloading. But this is actually a very common misconception because Python actually does, and it even has it in its standard library. The only difference is that the implementation is very different to how it is in a lot of other languages. There are also two very different implementations in Python, one using the standard library and the second more fully featured variation of it provided by a third party. So in this video, I'll be showing you how to do the simplified version with the standard library and then the more complicated but more fully featured version using the third party package, which means this will be the first video in the channel's history to be both part of the Python is Awesome series and the Python Plus series, which I can guarantee is not going to get confusing at all. If you find this video helpful at any point, then consider liking to let me know and maybe subscribing if you want to see more videos like this. If you want to support this channel monetarily, you can do so by either becoming a member or a patron. All the information you need is in the description below. For those of you that don't know what I mean by function and method overloading, let me quickly explain it for you. So in C or other languages, I'm going to be using Python code to make this easier to explain, but you'd have something like this where you'd have like an int or an add function, and then that returns x plus y, and it would take ints, and then you have a second one that took floats or the language equivalent type, whatever that might be, and that would also return x and y. And both of these functions would exist in the namespace at the same time, and whichever function was called would be determined by the type of the arguments that were provided to it. So for example, if you provided two integers, then it would run this top one. If you provided two float likes, it would run this bottom one. In Python, we don't have that. Only one function or method can exist in a namespace at once. And it's not really as vital to have something like this because Python has dynamic typing, which means that any function can accept an argument of any type at any time. But there are certainly instances in which you would want to use function overloading because it cleans up the code. The other option is to use if is instance checks. And while those are useful in their own regard, having this huge monolithic function that handles multiple different types isn't necessarily the best way to go about things. This functionality is called dispatching, and in our standard library we only have single dispatching, and in our third-party library we have multiple dispatching. So in the case of single dispatching, the function to be run will be determined by the type of the first argument and the first argument only. In multiple dispatching, it would be determined by the type of every argument present. If we were happy dispatching using the first argument only, then we could do from Functools import single dispatch. I've done a video on the rest of Functools, or like a good chunk of Functools already. That'll be in the cards if you want to see it, because it is a very nice thing to have. And then we can decorate a function using single dispatch, and we're going to say our function is called describe, and then we pass an argument which can be basically anything, and then we're just going to return unknown type in here, and this will serve as our base function or default function. So when we define all our other alternative functions, we'll define them all with types, If none of those types match, then this will be run. So if you want to return, then you can. You can also raise not implemented error if you feel that's better for you. But to register other functions, we just need to use describe.register. And then we can define our function and call it anything. A general convention I've seen is to name it just using a single underscore, which works for me. And then we're going to pass an arg there and say we want this function to take a string. There are two ways that we can tell this function to call on a string. So we can either pass it as an argument to the decorator here, or we can use a type hint. Either way works. It doesn't matter which you use. But yeah, if your code is typed, then you will already be using type hints. If your code is untyped, then you can just pass it to the decorator if you really want to. And then we can have, say, another one that takes both a list, a tuple, and then also a set. I don't know why I said both when there was 3 options in that list. But if you want to do that, then you can either use the union type or the pipe, or if you're going the untyped route, then you can pass it like that, and then have a tuple and a set like this. So you can use decorator stacking on these when registering, and that's the easiest way to register multiple types. You can use the union syntax in here, but I think at that point you might as well just pass it as a type hint, to be perfectly honest. And then if we wanted to do something like this, we could do a type, we'll just say we'll keep it simple, a collection of 3, if it is 3 elements. There we go. It's just my example has 3, so that's why I thought of that. And if we wanted to do a numerical one, then you could do describe.register and then int and then float and then def arg like that, and then we can do return a number. I'm going to give you a free hint while we're here. Instead of doing something like this, you can do from, I think it's numbers import number. There we go. And this type can be used instead of this like that. And now we take any numerical type we want and it will return and it will say that it's a number. So if we do if name equals main down here, like this, our run guard that we do in every script. And then we do print describe hello world, it will say that that's a string. If we want to describe a list like that, it will say that it's a collection. And if we do something like this, it will say that it's a number. So if we then run that like that, we can see that our first element, which is hello world, is a string. Our second element is a collection of 3 elements. And our third function is a number. If we then pass in something that it doesn't know, so let's describe, I've done that wrong. Let's do a dict of, say, 1 equals 1, and then 2 equals 2, like that. Because we haven't given it an overload, then it will say that it's an unknown type. It defaults to this one, which is our base function that it runs if no types match the ones we've overloaded. So this is just a really nice way of cleaning up your code if you have, a complex logic pattern that requires working through multiple types, for example. You can also do this in a method if you want. So I'm going to do class test and then bring these all in. And then instead of single dispatch, we're going to import single dispatch method. And then this is going to be method as well. We just leave these as describe.register because it will be able to tell that. And then we define an instance here. And then we do t.describe. And then I have messed that up. Oh yeah. We need to provide the self argument to each. Yeah, and the difference between single dispatch and single dispatch method is just that the self argument is ignored when dispatching. And now it will run exactly the same using the method. One important thing to note is that single dispatch does not limit you to a single argument. A function or a method that's overloaded in this fashion can take as many arguments as you want, but as I said earlier, only the first will be used to determine which function is actually called. This was an intentional decision, and I forget which PEP number it is, I'll put it on the screen. But the idea was that having multiple dispatch in that way, especially in Python, was a bit of an anti-pattern, and it made the implementation a lot more complex, where a lot of people probably wouldn't need that extra functionality. But if you do need that extra functionality, if you really, really need it, then some people in the world somewhere have got your back, because they have created a Python package that can do that. So if we do multiple.py, and then we open up our console, and if we do pip install multiple dispatch. Now take care when writing this. If you're used to calling it multi-dispatch for whatever reason, multi-dispatch is a package, but it's a significantly older one that hasn't been updated in about 10 years, and it's not the same one. The multiple dispatch is the one you want. I already have it installed. As of recording, the latest release is 1.0.0, and it has been for a little while. I think it's at the point where they've kind of added everything that they wanted to. But if we did from multiple dispatch import dispatch, and then for the sake of our types in the example that I'm going to use, we want to do from numbers import number again. And this dispatch works very differently. It works more similarly to other languages. So you have your dispatch decorator there, and you have your function here. So we'll use the add example from earlier, and then we'll create one that can take any number and any number, and then it returns a number, and then we have return x plus y. You can also pass, say, number in here like that, and it will do the same thing if you have untyped code. But if you want to define our default, we use dispatch again, and then we define another function called add, and then we use object as our type hints, or type, I guess, declarations. And in this instance, we're going to return a string, and we're going to simply string concatenate the two together, like that. So we'll use the string representation of the object to construct a string using the plus. It's just an easy thing. You can also have a varying number of arguments if you want. So you can do dispatch, and then we can have add just x number, and then we return a number, and then we're just going to return x plus 1 out of this. So if we did if name equals main, and then print add 1 and 2, print add, say, 1.6, and then print, I don't know, add, say, a string and a bool. That'd be an interesting example to have. And if we run py multiple.py, we can see that in this first example, we got a result of 3, meaning it added 1 plus 2 together, so it used this one here. In the second example, we only passed one argument, and it returned 2.6, so it ran this one because it just added 1 to the number we passed. And in our third example, we got 1 plus true, so it's created a string using a string representations of our object as our default, because object is kind of, well, I suppose if you wanted to get a default, you could put type in here if you really wanted to, because type is the superclass of object. But I think object is probably the safer one to do. I think maybe if you did types, you might have slightly different intentions for those. If you do something that's invalid, so say if we did add and then just like a string of the number 5, we'll get an error, and it will give you quite a concise or quite a verbose error actually. It will give you a not implemented error, could not find signature for add, and then our string type, because we haven't defined anything that only has one object. We defined something for 2 objects, but we never defined something for just one object. So it will complain at us in an error. In theory, you could also use this multiple dispatch to create a strongly typed function. So you could, if we got rid of both of these, just have that one, and then if it found anything that wasn't that, then it would just error for you. So in this case, we've passed something there isn't two numbers, and it will just error. And it would do the same for this. There's nothing for string and ball, so it would just immediately error. So you could use multiple dispatch to enforce strong typing if you really wanted to. So if that was something you were interested in, then that's potentially an option or an avenue you could take. So that is everything that I wanted to talk about with regard to